I'll try sharing my screen. Okay. So this is showing up okay?
Yes.
Fantastic. So, oops. Okay, so yes, as Valentina said, welcome. We're really glad to have you here. And we're going to start off this morning with a showcase and live demo of PlasmaPy. And I'm going to put a link to a notebook in both the chat and in Discord. And this link is a way to follow along with the live demo. So it'll open a link in your web browser. It might take a few minutes to spin up, but hopefully it'll be quick. And it will also time out after 10 minutes of inactivity. So I'll try to make sure to post that again in a minute for anyone who shows up late. All right, so what is PlasmaPy? The mission of the PlasmaPy project is to grow a fully open source software ecosystem for plasma research and education. By software ecosystem, we mean a set of software tools that grow together, work together, and are interoperable with each other and can be used for all aspects of both plasma research and for learning plasma science. Oops. And some very good news is that version 0.8 of PlasmaPy was released just this last week. And if you want to learn more about it, we have a documentation page, docs.plasmapy.org, which you can learn more about the new features and go through some of the example notebooks that we have to get an idea. And we'll be going through some of that content here. So to give a really high-level overview of PlasmaPy, we have a couple of different subpackages. The first one is plasmapy.particles, and that includes object-oriented and functional interfaces for accessing basic particle data. So if you want to know the mass of a singly ionized helium atom or something like that, then you can get it. The next one, which we'll also cover in this demo, is PlasmaPy.formulary, which is based off of largely the NRL plasma formulary. And it includes things like calculating gyro radii, other things which I can't remember at the moment, inertial lengths, alphane speed, and then a bunch of Brzezinski transport coefficients. We also have a dispersion relation solver that a few of us on the Zoom call have worked on. So thank you for that, Ramiz, Elliot, and Shane, and Eric, and anyone else who I'm missing. And with that, you can get dispersion relations for plasma waves in particular. We also have a few packages related to analysis and diagnostics. So we have some capabilities regarding Langmuir probes and Thomson scattering, charged particle radiography, and things like that. We also have a couple more subpackages that are in earlier stages of development, like PlasmaPy.plasma, which has base classes for different plasmas, and PlasmaPy.simulation, which we're hoping we can grow into some tools, some building blocks for plasma simulation. And there are many ways to be part of this community. We have weekly community meetings on Tuesdays at 2 p.m. Eastern. We have weekly office hours Thursdays at 3 p.m. Eastern. Neither of those will be happening this week because we have the Hack Week, of course. We have an Element chat room, and and it's also really helpful if people from the broader plasma community are able to request new features on GitHub. It's really exciting when we find a new feature request. And of course, we can also contribute code documentation and tests, and also participating and even organizing community events like this one, like Plasma Hack Week. So for today, we're going to cover a couple of the fundamentals for using PlasmaPy. And I'm going to put the link in the Zoom chat again if you want to follow along with the notebook. So we want to cover astropy.units, which we use for kind of ubiquitously throughout PlasmaPy, PlasmaPy.particles, and then PlasmaPy.formulary. So all right, see if I can over to the notebook. All right, how's the font size and everything? Does it look good?
Looks good to me.
Awesome. Okay, cool. So we're gonna get started by going a bit over astropy.units. And I should make sure that I have my notes here so that I can actually do this. So when we do scientific computing, oh, sorry, one preliminary. Please feel free to follow along with the link that I put in the chat. And also, please feel free to, like, we encourage you to ask questions here and on Discord. And I'll try to follow along with the Discord and Zoom chat also. And then this is using a Jupyter notebook. And the most important thing about a Jupyter notebook is that to execute a cell, we press Shift and Enter. And also feel free to give me a reminder in case I need to slow down. All right, so starting with astropy.units. In general, in scientific computing, when we want to represent a physical quantity, we do so using a number. So something like distance in kilometers.
I think some people are having trouble with the notebook, Nick.
Okay. If you try going to the link again, that's probably the best option that I have. It might take a few minutes to open up.
So to be clear, when I was navigating through the link, I was able to eventually I'm working on trying to get a video, but I was able to get to a launcher that contained like the group of files, several subfolders, docs, hack, requirements, resources, etc. But I could not find the specific file you were using, and it wasn't obvious where to go from here. In other words, this did direct us to the PlasmaPy, to a PlasmaPy directory, but it didn't seem to be the one that we need because it said the binder is not. We need a new binder, as several people in the chat mentioned.
Oh, okay. Let me try spinning that up again.
Nick, if I may.
Uh-huh.
There,
all you need to do, sorry if I'm stopping, but you can go to the resource folder and then the demo file folder. That would be the one you need to go to. If you already access the repository, you can just go to the resource folder and then the demo file is the one we're on, I think.
That is correct. If you go to the most recent link I put in, it should go directly to the notebook. So does the one that I just put in work for y'all? Or are you getting the same issues?
Right.
You may not have sent that
Yes.
to the entire group. Check
No, it's to
sure
everyone.
you have it sent to everyone.
Yeah, it's sent to everyone.
Yes. So your link, Eric, works.
Okay.
So it should work for
You
everyone.
gotta scroll up 1, 2, 3, 4, 5, 6, 7, 8, 9. About 10 messages up in the chat. You'll see my link.
It's weird. It says 500 internal server error for me. Eric, your link.
My link does?
Yeah, though I'm able to access it using Nick's link.
Okay.
Yeah,
But
someone
you're
else is also getting the same error as me.
No, my error was actually from from Nick's link, and the link from Eric works.
Okay.
So for the next link, as someone mentioned, if you click on it, it says that try accessing it from here, and when you click on here, it goes to the binder. It launches a binder. It just takes some time to go through it, and then it works.
Hey Nick, why don't you, since you have the website open, why don't you go through the process of launching it so everyone can see?
Okay.
It might make things
All right.
easier.
So I just put the link into the chat. And oops, here's what I just opened. So it should take a moment, and then this link should pop up. So apologies for getting the wrong link in there. Not sure how that happened.
Nick,
There's a saying.
For those that end up seeing the package structure, why don't you show them what the repo looks like a little bit, and so they know how to navigate to the actual notebook.
Okay. All right, so it should take a moment. And then should be files. Where is it? So under resources, and then it should be PlasmaPy demo.ipynd. So it should be in the resources folder, and then PlasmaPy demo.ipynd. We'll get to it. All right. Sorry about that. But the most recent link that I put into the Zoom chat and on Discord should work. There's a saying about live demos, which is never do live demos. So apologies for the mix up here.
Sorry, but even the latest link still says binder inaccessible, but then it also says you can get a binder for this repo by clicking here, which works for me. So yeah, just wanted to let you know that didn't change anything, but at least I can access it now.
Well,
Okay.
admin said internal error. I really don't know. Okay, but continue your presentation.
Okay, I think refreshing the page can often help. Let's see, there's also a limit of 100 people who can open it at a time, but I don't think we'll run up against that. So, okay. Take two. All right. So we'll often represent physical quantities as numbers. So distance in kilometers could be something like 40. But doing that has a whole bunch of risks. So we might accidentally perform operations with like adding something in meters to something in kilometers, or add something like length plus time. And these errors can go hidden, and occasionally they can cause Mars probes to crash for really expensive errors. So we're going to start off by doing a quick overview of astropy.units, and in particular focus on the functionality that we need for PlasmaPy.particles and PlasmaPy.formulary. So we usually import astropy.units as U. So I'm going to press Shift-Enter to execute that cell. All right. The way to use units is to multiply it or divide a number or array with a unit. So something like distance equals 60 times u dot km. So distance equals 60 kilometers. And when we do this, and so we can help print it out also, print distance, then Shift-Enter again. And what happens here is that when we multiply the number by a unit, we get a quantity. And so let's do type of distance and shift enter again. And it says that AstroPadded_units.quantity. We can also create a quantity object with compound units. So something like 88 times u dot imperial dot mile divided by u dot hour. And then shift enter again, and we get 88 miles per hour. And for those of us in the US who are used to imperial units, we can use the imperial subpackage. Oh, sorry, was there a question? Okay. And we can also create a quantity
I
based.
love the reference to the flux capacitor.
Oh, yes. I was wondering if anyone noticed the Back to the Future reference there with 88 miles per hour. We could also do 1.21 gigawatts. All right. So if we import NumPy as NP, and then regular enter, and then do np.array, and then let's say 2, 3, 4, and then multiply that by u dot kilograms, then we can get a quantity where it's actually an array. So we can use quantities like this also, which is really handy. All right. When we do operations with quantities, the unit conversions are handled automatically. So we can do 1 times u dot m, 1 meter, plus 25 times u dot cm, and then press shift enter, and we get 1.25 meters. So it'll generally take the units on the left. And if we try to do something like meters plus seconds, then we will get an error. So it's a way to double check what we're doing. And units also get handled automatically during operations like multiplication, division, and exponentiation. So if we say distance equals 80 kilometers, and then time equals 2 hours, and then velocity equals distance divided by time, and then print velocity, and shift enter, we get that the units are handled in this operation also. One thing to note is that most of the functions that we use in packages like NumPy and SciPy, those can usually be used with quantity objects. So they're usually compatible with AstroPadded units. But there are a couple of functions where this isn't true, that quantities might lose their units, and that's due to some design issues with NumPy that are gradually being worked on. When we have a quantity, we can also convert it to different units. And the way to do that is with the to method. So we created velocity up here, and we can do velocity dot to, and then meters per second. And then we can convert this to meters per second. So those are the fundamentals of AstroPadded units. And for a lot more examples, we have a notebook in PlasmaPy's documentation, getting started section, which goes through in a bit more detail, including how to work with units like electron volts, which we often use as temperature. All right. I also wanted to mention that AstroPy has another subpackage called constants, where we can access things like the speed of light and all that. So I'll press Shift Enter here, and then print C. And so we imported the speed of light and printed it, and it includes the value and also the uncertainty and where the value came from, so which standard. So it's also pretty handy, since some fundamental constants, the values tend to get refined. They change over time as experiments get better. Okay. So the next subpackage that we're going to go into is PlasmaPy.particles. And this is one of the first subpackages that we implemented with PlasmaPy. So we went about thinking, oh, let's create a function for the alphane speed. And then, oh, we need a way to get the masses of ions. And then a month later, we had PlasmaPy.particles, and we could write the alphane speed function. So let's do from PlasmaPy.particles import star, and then Shift Enter again to do the import. And there are a bunch of different functions in PlasmaPy.particles that we can use to get information about the different particles that we might end up interacting with. So let's do this with atomic number. Atomic number of, say, Fe for iron, and Shift Enter, so we get 26. The input to most of these functions has to be some representation of a particle, and there are a lot of ways that are valid representations, so the inputs are pretty flexible. We can, in addition to using the atomic symbol, we can provide a number which will represent the atomic number. So if we do element name of 26 and press Shift Enter, we get iron again. We can also provide standard symbols for the different particles. So we can do is stable of E minus, so is an electron stable, and get true, it is stable, which is good. The universe hasn't changed while I wasn't looking. I can do charge number, also known as the integer charge or charge state of a particle. So proton, and we get that a proton is 1 in units of the elementary positive charge. And we can also, for some particles, use the symbols directly. And one example for this would be the alpha particle. So one trick which works most of the time when we have a Jupyter notebook, but not always, is to do particle mass, and then in quotes, you do LPHA and press tab, and it will turn into an alpha Unicode character. And then we press Shift Enter, and it'll give us the mass of an alpha particle, a doubly ionized helium-4 particle. So this, I think, doesn't work on
Nick,
Google
can you
Colab,
go back over how you got the representation of the Greek letter alpha?
Sure. Did the LaTeX symbol, so the, I think, / or backslash, I can never remember, and then type out alpha, and then press tab. So we can also do this with beta, so the /beta, and then press tab there too. So it's a pretty handy shortcut that Jupyter Notebooks lets us do. But if we didn't want to do that, we could also type out alpha as a whole, and that will also work. Yeah, this is a pretty neat feature of Jupyter Notebooks, which I just learned about, I think, last year after using them for a long time. And it should work for any Greek letter, and I think a bunch of other LaTeX symbols, though not all of them. But yeah, that is a really helpful trick to be able to use. Okay. So if we wanted to represent a particular isotope, we can do that with a string containing the atomic symbol followed by a hyphen and the mass number. And we can do that with half-life. And let's pick carbon-14, one of my favorites, and press Shift-Enter. And it'll give the half-life as a quantity in seconds. And so, again, 14 is the mass number, the sum of protons and neutrons in the nucleus. We can go beyond that and represent an ion. So we take an atomic symbol or element name, and then in addition to the -14 for the mass number, we can include charge information. So let's get the charge number of, let's say, iron 56, and then 13 plus. So an iron 56 atom that has been ionized 13 times, has lost 13 electrons. And then Shift Enter again, and so we get 13. And the inputs to PlasmaPy particles are really flexible. So and in terms of the strings that we can use to represent particles. And we call an object particle-like if it can be used to represent a physical particle. So if we wanted to do something like particle mass of iron, spelling it out, 56 plus 13, that will also work. And we can do particle mass of iron 56 plus 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 plus, and get the same value. Okay, good. Looks like I did count it right. It's hard to count above 5 sometimes. Most of the functions that we use also take additional arguments, like Z, which represents the charge number of an ion, and mass num, which represents the mass number of an isotope. And these arguments are often keyword only to avoid ambiguity. So if we do particle mass of Fe, and then comma, Z equals 13, and mass num equals 56. And then Shift Enter again, and we get the same particle mass. Right. And apologies if you hear traffic in the background here. So far, we've been using a whole bunch of functions for accessing particle information. We also have a particle class, which we can use to create particle objects, and then get particle properties from that. So let's start this by defining a few of these. So a proton will be particle of P+, and then electron equals particle, and let's spell it out this time, of electron. And you can also do iron 56 nuclide equals particle of Fe, and then want to specify the charge number So Z equals 26. So it's fully ionized. And then the mass number is 56. We can define, we can create proton, electron, and iron-56 nuclide as particle objects. And once we've done that, we can access different particle attributes. So if we want the proton mass, we can do proton.mass. And if we want the charge of an electron, we can do electron.charge. And we can get the charge number with electron.charge number. And we get that it's -1 in units of the elementary positive charge. And then for isotopes, we can also get, for iron-56 nuclide, we can get things like the binding energy. And press Shift Enter for that. All right. And if we wanted to, since this is a quantity, we can convert that to, let's say, MeV, so mega electron volts, and get that the binding energy of an iron-56 nucleus is a little under 500 mega electron volts. We can also get the antiparticles of fundamental particles by using the antiparticle attribute of a particle. So if we want to get the antiparticle of an electron, we can do electron.antiparticle. Shift Enter again. And so we get a particle representation of a positron. We can also use the tilde operator on a particle to get its antiparticle. So it's a tilde of a proton, and it'll convert it to an antiproton. One of the development techniques that we often use in PlasmaPy is procrastination-driven development, and this is one key example of that. So this is a pretty fun thing to implement, even if it's not all that useful. It can still be useful. All right. We also have ways to ionize and recombine atoms and ions. So let's define a deuterium atom. So deuterium equals particle, and then D0+. So we want to specify the charge when we do this. And then we can do deuterium.ionize and press Shift Enter, and it will give us a deuteron, a singly ionized deuterium atom, so a deuterium nucleus. All right. And we can also provide a number to say how many bound electrons we want to add or remove. So we defined an alpha particle already, I think. I'll do it again just in case. So alpha equals particle, then we can spell it out. And then alpha dot recombine, and let's say 2. And we'll get, go from a doubly charged helium-4 particle to a neutral helium-4 atom. All right. We can also use custom particles, which are, so if we're doing a simulation or trying to represent a dust particle or something like that, we can specify the charge and mass of a particle manually. So if we type CP equals custom particle, and then let's say 9e minus 26 times u dot kg, and then let's see, 2e 2.18 e minus 18 times u dot c. So 18 kilograms and, oh, sorry, 10 to the 10 to the minus 26 kilograms and 2.2 times 10 to the minus 18 coulombs. And then we can get the mass of it, just like for a particle, so CP dot mass, and we can do CP dot charge. And the one thing to note is that custom particle objects are not yet able to be used in PlasmaPy formulary, but we're planning on doing so by the next release. So hopefully by the end of the year, we'll be able to use them. There's a question in the chat. When you do deuterium.ionize, does the variable deuterium now refer to D1 plus instead of D0 plus? So we can try that. I'm going to press B over here to add a few new cells. So I'm going to re-execute the cell, and then we can print deuterium again. And so though we did deuterium.ionize, it didn't end up changing deuterium itself. But if we do deuterium.ionize and then set in place equals true, then print deuterium, then the object itself will have changed. So that's a really good question. And actually, I was trying to cut down material for this demo, and that was one of the parts that I deleted. So probably shouldn't have deleted it. Next time I can leave it back in. And there's another question. When you define a custom particle using custom particle, what are the inputs and how are they parsed? Is it always mass, charge in that order? And I'm going to press B to create another few cells again. And we can do help of custom particle. And this will show the doc stream, the documentation for custom particle. And it will show the parameters that we have present. So the mass, the charge, and the symbol. And if you're going to put them in without keywords, then they would have to be in that order. But we could also change this to CP2, second custom particle, equals custom particle of charge equals 20 minus 17, 18, and then mass equals 3e minus 26. Oh, and I need to add coulombs, u dot c, and then kilograms. So we can define one or the other of these. We can also create a custom particle without any arguments. And if we do that, so something like custom particle, no arguments, dot mass, we get that the mass is not a number, kilograms. So this is a way to allow these to be undefined. So yes, that was a good question. Oh, and one other thing, which I should have mentioned, there's a new function that was added for the last release, and that's molecule. And let's say if we want to create a water molecule into H2O, I think I have that right, and it will create a particle which has the mass of a water atom and the charge, and then it'll also record the symbol. So yes, that was a really neat thing to have added. And I'm hoping that we can expand the capabilities for that in the future, though it's there are a lot of details that need to be worked out. Okay. And then, okay. The next type of particle object is a particle list. So let's define iron atoms as particle list. And then in parentheses, we want to create another list. So square brackets. And then FE, let's say 12 plus, FE 13 plus, and then FE 14 plus. All right. And now that we've done that, they've created iron atoms as a particle list. And we can do iron atoms dot mass, get the mass. We can do iron atoms dot charge to get the charge. And we can do iron atoms dot symbols to get the symbols. So if we want to do something with a bunch of different particles, then you can use particle lists. And one other thing to note is that, like custom particle objects, we still have to make particle list objects compatible with the functions in PlasmaPy formulary, and that's something that we're planning on doing for the 0.9 release. So that's a feature that we're hoping to add soon. I guess two last things for PlasmaPy particles. Often we'll want to write a function that accepts a particle as an input. And for that, we can use the particle input decorator. And in case you're unfamiliar with a decorator, I included a link in the notebook. To be concise, it's a function that operates on another function. So if you want to process the inputs to a function, or process the outputs, or do a log, then a decorator is the way to go about it. So after we do at particle input, then we can do def of f, and then have an argument particle, and then we put in an annotation. And the way we do that is with a colon after the name of the argument. And in this case, we're using particle as the annotation, and then press colon. And then we can do return particle. So if particle input were not here, this function would return the same object that it was given. Well, let's see what happens when we do f of p plus. So where p plus is a representation, is a particle-like representation. And this is showing a name error. F is not defined. And this means that I did not press Shift Enter here. So we can try that again and get f of p plus returns a particle. So what particle input is doing is taking something that's particle-like, a string or integer representation, and then returning the particle object. And that can simplify a lot of code. So it's a pretty fun decorator to work with. All right. So we can also use PlasmaPy.particles to calculate energies of, for example, nuclear reactions. And with that, we can use the greater than operator. So let's say deuteron equals particle of E plus, regular enter. Triton equals particle of T plus. Alpha equals particle of alpha. And then neutron equals particle of neutron. And then shift enter. And then we can do, oops, energy equals deuteron plus triton, and then the greater than sign, alpha plus neutron. So this is the D plus T turns into an alpha particle plus a neutron. So for fusion energy scientists, this is something that you should be well used to. And then we can say energy dot to and convert it to MEV and shift enter. And invalid syntax. And so it's pointing to here. So that means I have an extra period. And it gives us the familiar 17.6 MEV value. All right. So the next part that we can cover is PlasmaPy.formulary. So I'll press shift enter again to do this import. And we'll go through, we have time for one example of calculating plasma beta in the solar atmosphere. And for those who are new to plasma physics, plasma beta is something that comes up pretty often. And it's the ratio of thermal plasma pressure to magnetic pressure. So when beta is really big, much greater than 1, the magnetic field is really strong. Oh, sorry, is small compared to, is relatively small. And so magnetic field isn't able to operate, it's to alter the dynamics. And so for really high beta, the plasma motion is more reminiscent of gas motion. When beta is much less than 1, magnetic tension and magnetic pressure dominate the dynamics. So let's use beta, the beta function in PlasmaPy.formulary for different parts of the solar atmosphere. And the notebook already has a few values of the plasma parameters for an active region in the solar corona, so a place with a relatively strong magnetic field. So we're shift enter to execute that. And then we can do beta of T corona and corona and E corona. And then we get that plasma beta in the corona is about 0.1%. So beta is really small in an active region in the corona. So the magnetic field is what governs the dynamics much more than plasma pressure. All right. Now we can dive deeper into the solar atmosphere. There's a question about how do we know to write beta of different, like the different order. So I'll press B to create another cell here, and then we can do help of beta. And then this will give us the parameters that we can use to add things. So I did a shortcut and put them in the order that they're given. But for the next one, let's do this. So beta of T equals T photosphere, N equals N photosphere, and then B equals B photosphere. And then we get, so in this case, we can put them in any order. And so the code is a little bit more cleaner when we put the parameter names here also. Then we can do, wait, no, we can go down. So we can also think about what's happening in sunspots. So beta is pretty large in the photosphere, so the magnetic field isn't going to be that important in governing the dynamics. It'll affect it some, but the sunspots are the places where the magnetic field in the solar photosphere is largest. So let's press Shift Enter to execute that, and then do beta of T equals T sunspot, B equals B sunspot, and then we can use the same number density as the photosphere, and then Shift Enter, and the syntax error positional argument follows keyword argument. This means that I forgot to put N equals here after doing that for this. Right, and we get that beta is about 0.4 in the solar photosphere, and that means that the magnetic field and thermal pressure are both important, but the magnetic field is a little bit more important. All right, and I said for the next session if time permits, and it does not. So we'll end up finishing there. And these notebooks, if you go to PlasmaPy's documentation under examples, you can find these and a bunch of other ones. So, all right, I'll stop there. And if there's anything, please feel free to bring up any questions or add any thoughts. All right, yeah, I lost the Zoom chat, so. All right.
Nick, did you see that comment?
I did not.
So since it's 2022, can we write T COVID instead of T Corona?
Yeah. One of my jokes at work for the beginning of the pandemic was, at least it's not chromosphere virus. And nobody thought that was funny. And I still don't think that's funny.
Similarly, this one's only marginally funny.
Yeah, I nearly spat my drink when you said that.
Sigh. Hopefully one of these years we'll be able to have Plasma Hack Week in person, or at least hybrid.
That goes right up there with the 1.21 gigawatts.
True. Okay.
So I'm just going to give you an overview of what the week is going to look like. And basically to give you a feel for, hopefully to increase the participation and collaboration, because one of the things that we took away from last year's session was just that, you know, we missed out on, we did a lot of talking sessions and training, but we did not do. It seemed like we could improve on participation. So this year, that's really what we're going to try and do. And the way that we're going to do that is we've made the emphasis on building a hack package this year. So, you know, when we get to the second part of the session, one of our main objectives is to develop the formulary. And so we'll talk more about that as we get to it. But overall, the reason we're doing this is because our intent is to train our scientists so open source software can thrive throughout the plasma community. So that's really the goal. We really want to increase the awareness and participation and collaboration within the community. So with that being said, some of the aspects of collaboration this week are coming from our Discord. And actually, let's look at the first place I'd like to show you before we get to Discord is just our Hack Week PlasmaPy website. So if you come to, you can either get there through the PlasmaPy main page, which I will type right now, and then you'll see an icon to click on Hack Week. Alternatively, if you're just there, you can click on Hack Week, and you'll see up here a link to Discord. Actually, we have it in many different places, and I was trying to figure out the best place to show you. But in this case, we have it up here. If you click on Discord, you can either sign up for the channel. Yes, I have it already launched. And when you come in here, you'll be added to our Plasma Hack Week Discord channel. And the first thing I want to encourage you to do when you come in is go to the introductions page. When I find it, there we go. And many of you have already started introducing yourselves, but feel free to come in here and let us know who you are. Tell us a little bit about what research you're doing, what your interests are with PlasmaPy. We'll try to work our way through it and hopefully understand better what the community is looking for and what the community wants. On top of that, we have some other channels. We have a welcome channel, main. We have a questions channel and a help desk channel. There's also work on the website, registration form, which actually, I'm not sure. I guess you can still register if you need to. And channel requests. If you feel like there should really be a separate topic, feel free to submit a request here on the channel requests, and we'll be happy to create a separate channel. And yeah, so that's pretty much that. Let's look at the schedule now. So when you come here, we have information about what the Plasma Hack Week is about. We have registration, and then we have the schedule. And the way that we've done the schedule is, as you can see here, the first couple of days are intensive on beginner type activities. So, you know, we're going to start with just simple stuff like installing Python. We'll be getting into later after the social hour, information about terminals, integrated development environments, and virtual environments. And then day 2, we'll be talking about Git and GitHub. You'll notice that we've spent a lot of time on Git and GitHub. And that's because we feel like really with the collaborative development, this is the heart of what you'll need to be, to be a contributor or even just a user. Then we've also provisioned here in the afternoon. Well, I hate saying times, but you can see our time here. And if you're not in one of these time zones, just adjust. But we'll have lightning talks, and these lightning talks, we've had some invited speakers or some people that responded that they want to give a 5-minute presentation on lightning talks. We'll talk more about that later. But if you are interested in participating in lightning talks, there's still an opportunity to participate. And did it say who to contact? Yeah, if you want to, I'll put this in the chat right now. If you'd like to participate in the lightning talks, I'm putting a link right now. Send a link to hack@plasmapy.org, and we'll be happy to consider it. Not everybody that submits a request will get selected, but we welcome as many people participating as we possibly can. So day 3 and 4, we're really going to try and get into hands-on development. And so with that, we're going to be working on the formulary and PlasmaPy.formulary. We can also work with other formulary. You know, I have a personal interest in fusion type formulary, so we might be getting into that. If you have some other suggestions, we'll have the opportunity to do breakout sessions and suggested breakout sessions. We're going to try and be very dynamic with what the needs of the community are. Briefly show an open issue. So one of the ways that we're managing communication is through GitHub. And within GitHub, actually, let's go back to the main PlasmaPy Hack Week. Repositories, Hack Week. Okay, so we're managing discussion topics through the issues page on the PlasmaPy Hack Week repository. So you can see in here, there's suggestions: implement an X-ray Thomson scattering module, implement diagnostic coordinate transformation tool, implement radiative and through body recombination. If you can look at these and see some ideas of what have been suggested. And if you would like to suggest more, feel free to go in here and post a new issue and describe, a little bit about what the idea is. And if we can find enough interest, we can have a breakout session and maybe work on that this week. So the CMA diagrams, you can see a lot of different ideas that have already been posted. But please feel free to increase the number of suggestions. And with that, see, I feel like I've covered pretty much everything. But does anybody else have anything that I missed or things that we should emphasize?
There was a question in the chat about how will the social hour be?
That's what that's kind of what we were doing earlier. I think the social hour is just going to be an open session where we can just talk to each other. We can respond. Do you want to have breakout rooms, Eric, that different people can socialize on different topics?
We can do agile meeting. So if people want their own breakout session, we can surely make a breakout session so people can chat there. Help facilitate the development of the community and encourage everyone to start participating in open source. So as we get through, the rest of today is going to be kind of just getting yourself set up, getting your Python set up and your development environment and everything like that. So as we go through this, feel free to ask any questions. Whatever time we have left at the end, we can stay around and help all of you set up your own environments. So I'm going to go a little bit through on a quick overview on how you get Python, and then I will hand it over to David, and he's going to cover Anaconda. And I've been trying to think of a good analogy to kind of compare the difference between just installing Python and using all of its tools versus using Anaconda. And this is the first time I'm using this analogy, so you can all tell me how good it is or not. I kind of feel like doing it with all Python tools or doing it with Anaconda is kind of like trying to cook a meal. The Python side is where you find your recipe, you go to the store, you buy all the ingredients, you come back and you put it all together. So you're basically doing everything yourself. Anaconda is kind of like a meal prep service, kind of like HelloFresh, where I have a recipe, I can order it, they send me all the bits, and then I do a little bit to put it together. It makes sense to me in my head. It's the best analogy I've come up with. So if you all have your own analogy, then I'm more than happy to hear it.
There are fortunately different levels of proficiency in those meal plans. So, you know, you can, it's all the way from ordering like meals to just basically ordering the ingredients and somewhere in between.
Yeah, there's definitely something different from a full-on dinner versus ordering ingredients for a smoothie. Okay, so I'm gonna get started. So as we'll mention, this whole week is going to be focused on developing a hack package, similar to like what PlasmaPy is, a Python package, but we ourselves, not just the organizers here, but all of you as well, will go through and help build it out so you can learn the tools that are needed to contribute to open source software. And so the repo associated with this is on the it's on GitHub on PlasmaPy's organization. So if you were to go to github.com PlasmaPy, so this is the main organization. And if you go to the Hack Week, this is going to be the repo for us. And as we alluded in Nick's talk, we have a resources director here. So this resources directory should have kind of all the presentation material that we're going through. So I've made my way here, and I'm going to start with this Python, PyPy, and pip. So this is the first thing I'll start with. So getting Python nowadays is there's several ways to do it. I find the easiest way to do it is just to download directly from Python. So if you go to Python's website, you can select which version you want to use, and you can directly download the installer. I've always found that to be the easiest way to do it, but there are many other mechanisms. For example, I'm assuming David will cover installing Python through Anaconda, so that's another avenue you can do. Now, for this Hack Week, well, I say stay away from Python 2.7 because that's legacy stuff. That's end of life. If we were doing this 5 years ago, there'd be a bigger debate about using Python 2 or 3, but we're well past that now. And Python generally schedules end versions for all the releases to be 5 years past their initial release date. And I have a link here to their table. So this is kind of their release table. So we can see that Python 3.11 is going to come out in a few months, and the most recent release is Python 3.10. So for this week, since we'll be using PlasmaPy quite a bit here, Plasma requires 3.8 or higher, but we do highly recommend installing 3.10, but either 3.8, 3.9, or 3.10 will do. I'm not going through the process of installing it here. If you guys have questions about installing Python, we can do that towards the end of the session. Now, a big part of this, a big part of working in Python is PyPy, Python's package index. So this is the location where this is the de facto repository for all third-party Python packages. So for example, if you ever install PlasmaPy, it is registered with this, and this is where you install PlasmaPy from. And you can actually come here, you can find out information about PlasmaPy. You can even look at its release history and go through and see all the past versions. And you can go through, like, if you go back to Python 3.6, you can see in this one does support Python 3.7. So you can go back and get some information about it.
Okay, your URL bar is very difficult to read. Where is the where is this PyPy located?
Okay, PyPy is just pypy.org.
I'll put a link in the.
Yeah, you got
Great.
that, Nick?
Thank you.
Yeah, and you can, if you're in the resources, you can just directly link that. And so I use the example of PlasmaPy. That's there. NumPy, which a lot of people use or are familiar with, is also located here. This is where all third-party packages are located. Okay. I guess I'm just looking at the chat. Are there any questions? Okay. Okay. All right. And then pip. Pip is Python's installer. It's the package installer for Python. It's the de facto installer. And so pip will directly pull, when you install through pip, it actually looks up on PyPy to find the package to install. It is written in Python. And so you guys, I'll just do a little demo here. So I'm using two different terminals here. I'm on a Windows machine, so I'm going to show this in two different terminals. But Nick, Will, and Nick will discuss these in a little more detail. So I'm running here essentially a Unix virtual environment is what I'm doing. So this is a lot like you would see on a Unix machine or on a Mac. And so in this case, if I do Python 3-version, you can see that I'm running Python 3.8. Can everyone see this all right? And so if I do, people will often see pip, but doing pip is usually just a shorthand for Python 3-m pip. So this is the setup I generally like to do, because that means I know I'm directly installing into this Python distribution that's on my machine. Some people might run into situations where they try to install something, but it's not available for them, and they start wondering why. And that's because the pip command is pointing to a different Python distribution than they're actually using. So this is a way to ensure that you're installing into the Python distribution you are working in. So it's Python. If I do show PlasmaPy, you can see I don't have it installed right now. So if I do pip install PlasmaPy, it'll pull it from PyPy and install PlasmaPy. So this will install the latest version of PlasmaPy, which is 0.8.1. Shouldn't take too long. This runs through, and we have PlasmaPy has a lot of package dependencies. So as it does this, it's resolving to make sure that it's installing all. It's installing the correct version of each dependent package to make sure everything will work with each other. Okay. So now if I do Python -3 pip show PlasmaPy, that will be installed, and I have 0.8.1 installed. So this is kind of how you do it with on the Unix side. On the Windows side, the command's a little different. You use py space and then the version of Python you want to install in. So in this case, I have Python 3.10, and then the rest is the same. So you do -m pip. If I do show PlasmaPy, I don't currently have it installed. So if I want to install it, let's say I want to install an older version, I can do install PlasmaPy == and I can specify the version I want. So this one will install an older version of PlasmaPy 0.7, which is not the latest release, but the one before that. All right, Paul was saying, I guess I'm mispronouncing it as PyPy. People often pronounce it as PyPy. Yeah, that's probably a good way to do it.
Oh, PyPI.
PyPI? PyPI. All right, well, thank you, Nick. I might still call it PyPy, but I'll try and be better. So, this one's taking longer than expected. All right, there we go. So now if I do install show PlasmaPy, you'll see 07 is installed. All right. All right. Any questions? All right, I'll hand it off to David then.
I have a question, if that's possible.
Yes.
So I just tried to install PlasmaPy, and at the very end it said successfully installed, but it showed also an error saying TIPS dependency resolver does not currently take into account all the packages that are installed. This behavior is the source of the following dependency conflicts, and then it talks about Spider and Anaconda. Any idea why that would be the case?
I think Nick, are you doing this through Anaconda, or are you doing this directly from a terminal?
I'm doing it directly from a terminal, Mac.
My first, I'll let Nick chime in on this, but my first suspicion is you might have already had another version of a package installed that is incompatible with PlasmaPy. So it's not uninstalling and installing a new one. That'd be my first take. Nick, you have thoughts?
Yeah, like sometimes the packages end up having conflicts with each other, and this one thing which we'll talk about later today is virtual environments, and actually what Dave is going to talk about right after this, Anaconda Navigator. Those can also help with issues like this. But sometimes we get warning messages for pip and it ends up being okay. So that might also be the case.
All right, thank you.
All right. So let me just introduce myself. I'm David, one of the PlasmaPy main people. But I have to preface it by saying I am not a computer programmer. I am an experimental plasma physicist, and as such, I tend to try to find the easiest way to do things. And so I've generally gone about doing things like Anaconda, where I don't really have to think about all of the things that Eric just talked about. I like downloading a program and having it work. And so what I'm going to talk about in a little bit is a program called Anaconda, which more or less you download and it works. It's not quite as simple as, installing Word or something and being able to type out a paper, but it is a little less it's a little less doing things from scratch, and kind of the analogy that Eric made was pretty good. It's sort of like there's some prepackaged things. I still have to do a little bit of cooking of my own, but things are a little bit more straightforward. And actually there, as I go through it, there are some things that do end up having to be done, for lack of a better term, manually, using something like PyPI, or some other way of installing packages, but you sort of get 90% of the way there using this, what's called Anaconda. So actually what I want to do is I want to first gonna first post a link on the chat, and I'll post it in the Discord as well in a moment. But so I made a video that just sort of walks through this installation process. It's unlisted on a YouTube page, but you're more than welcome to look through it. And this basically just walks you through the whole process that I'm going to do now. So I'm going to go through things a little bit more quickly than I do in the video. So if you miss something, hopefully you can go back to that and pick it up. As well as I think we're also going to be posting this stuff online as well. Let me start by showing you. Okay, I'm going to share. I'm logged in twice here, so let me share this screen. And we end up on the website anaconda.com. Now, Anaconda itself is a company that basically puts this together. So it's I think they nominally have some type of software that they actually you can purchase, but for anybody who is just doing coding kind of things, it's free and open to use. So if you go to anaconda.com, you can go through and go to download. Now I'm doing this on a Windows machine, but I found that the process for getting this installed on a Windows and a Mac is almost exactly the same. I think there could be a little bit more nuance going back to the way Eric was doing things, installing on terminal. I've actually had issues. I'm a Windows person. I've actually had issues getting students who are on Macs sort of getting up and running. Macs nominally have Python sort of natively installed, but then there can be version issues. And so a lot of times I'll just have a student who's a complete beginner just start with Anaconda even on a Mac, as just sort of the most convenient path to at least getting started. And if they want to dive more into the customizable world that you can do from the terminal, then they can do that on their own. So I would just go to download. There's different versions, of course, and it takes a while, but it's a standard process. It'll download, and you install it just like you'd install any other kind of software that you would on your computer. It does take a while, which is why I just wanted to show you that, and then now I'm going to switch over to what you get when you actually have it on your machine. So let me stop sharing here and go to my computer here. Let me bring up Anaconda first. All right. So when you open your the program, you'll go to, let's see, it hasn't started sharing yet. There we go. Is this? You'll go to Anaconda, your installation, and go to Anaconda Navigator. So there's a bunch of different sort of links that it opens up. Anaconda Navigator is sort of the place where is your landing place. And so you have home, and this gives you an overview of the applications that you can use. The majority of these are all just ways of interfacing with Python. So these are your IDEs, interactive development environments, some of which we'll be talking about later, things like VS Code and Spider. There are other ones that you can get installed. This is sort of what comes default, although you do have to install it. So you notice that there are some that I have not actually installed, whereas others I have already installed. So when you get your first, when you start Anaconda Navigator, you have to decide, which interface for coding do you want to use. When you install Anaconda Navigator, it will start off with what's called a base environment. So unlike what I have shown here, where I have a bunch of different environments, when you first start up, it'll only just show this one. I'm actually going through the installation process on this other computer. So if there's things that come up that I want to show you, I'll switch over. Eric didn't talk too much about environments. Basically, an environment is sort of well, I guess you did. You mentioned how you can have, right, Eric, you did talk a little bit about environments.
I mentioned it. I'm leaving the broader discussion for that for the virtual environments later today.
Okay. Okay, great. So, short story, the short story is that a virtual environment is sort of like a special area where you can have a particular installation. So you can have one virtual environment that uses Python 3. You could have another virtual environment that uses Python 2.7. And so you can have different versions of packages installed, and usually that is something that you do if you have certain packages that don't work well with newer versions. You can keep older. It's like basically being able to have all at the same time, your different versions of Word or even your different versions of Windows all at the same time that you can sort of access interchangeably. So when you first start, Anaconda usually gives you a certain set of base packages. And so this is where using Anaconda is actually sort of the easiest thing to do, because you don't have to worry about, oh, do I have this installed? Do I not have this installed? There's a lot of things that are already in there that you don't have to worry about. So when you want to code, you would just go to your environment. You can open up whichever form of terminal you would like. You can open up just a basic terminal. You could actually directly open up Python. You can directly open something called IPython, which is a little bit of a, we don't really talk about IPython too much, but for those of you who are unfamiliar, it's a little bit more geared towards scientific computing. It has more calculator-like properties than your basic Python application. You could also open with Jupyter Notebook. So IPython is sort of like using MATLAB. For those of you who might be familiar with MATLAB, Jupyter Notebook would be like using Mathematica. If you go back to home, you could also open up one of these IDEs. So for example, you can open up Spider and use Spider. Note you can select which environment you want to open up in. So again, I have the base root. That's the one that comes with your Anaconda installation. So if I were to open up Spider, it would use whatever versions of things are sort of loaded in this base version. Now, as you can see, I've created multiple environments here. We could actually create a brand new environment just to see how this works. So you would create an environment, choose what Python installation you have. Let's do 3.8. It also has R. You can integrate R with it. I don't usually, because I don't actually code in R. And this will create a separate environment. Now, you don't have to create a new environment when you start out. Like I said, you can just use the base environment, but it's good practice to sort of start in a new environment. One, because you can specify exactly what you want. And it keeps your things organized a little bit better. you know, and as you start working on things, you know, you can create environments. It just keeps things from getting too muddled. And if you avoid using the base, you know, you sort of keep the base pristine, you know, sort of as is. So let's go ahead and create this environment. It'll take a few minutes to sort of go through and create it, and you know, it will put in sort of all the basic packages that you would get in your base root environment. So this will take a moment. Let's see. While we're waiting, I'm going through the installation process here. On the other computer, again, I do go through the actual installation on the video kind of in an expedited way. So if you actually want to see that process, but it's like any other installation process that you would do, and you just kind of select through. Let's see. Are there any questions while we're waiting for this to load? Okay, mostly on using IDEs. That's a good point. Paul mentions about installing as admin super user. That's a lot easier to, generally a lot easier to avoid on Windows machines, because it's hard enough to sort of be in an admin super user state, but certainly on a Mac, that's something that you can accidentally do.
I like to point one thing out.
Sure.
So when I was talking about PyPI, that's the de facto third-party package repo for Python, and it's only in Python packages. Anaconda is a completely different third-party package repository. It is separate from PyPI. A lot of packages release both. A lot of third-party packages release to both places. One of the advantages of Anaconda is that it's not restricted to just Python packages, as kind of David hinted at earlier. You can also have R in here, and there's several other different languages. I don't remember what they all are though. And much like pip is used for PyPI to install packages, for Anaconda, you have the Anaconda navigator we can do here, but they also have their own command line installer called Conda that you can install directly from, that you can install with.
Yeah, I actually meant to bring that up, and that essentially you can think of Conda and PyPI as somewhat interchangeable in terms of Python packages, but yeah, as Eric mentioned, I think Conda has is a software package manager that can go beyond somewhat Python. Although, for example, and I'll show you here, and this might just be me not being you know, technically proficient enough to get it to work. But for example, I can't directly install PlasmaPy from here. So let me just kind of continue along here. So I've created this new environment, and so this is sort of the bare bones. It's got Python. You can see it's Python 3.8. It installs the latest version of pip. A few other things that just are necessary for being able to run. So I could open up a Python terminal, or open up a terminal and run Python, or I can open up Python here. So this is like the bare bones. You know, I can do basically only the simplest things. Oops, I can't code. So if I actually want to make this useful, I need to get all of the actual useful packages installed. So how would you go about doing that? Well, you can click on, right now the menu up here is selected as installed. You can select not installed. And you can see sort of at a glance all of the packages that are available to install that are not installed. You can see these are a bunch of R packages here. So most importantly, say we want to install NumPy. And if you search NumPy, you get sort of all of the associated NumPy things. So I usually select sort of the NumPy and sort of whatever else has the same version of that as your main NumPy one. So this will install NumPy for me, and I just hit apply, and it will install NumPy. So this is the exact same process, just in GUI form, as we did using as Eric did used pip, or how Eric used pip. Now I could have used the command line. I could have gone to terminal and did conda. I don't know. I actually don't do that very much. I usually just use this GUI version, but I think you can, in principle, type something like conda install NumPy, and it would do the same thing. But this is how you would install packages that are already in this database. And so for our purposes, you'd want to have NumPy installed, you'd want to have SciPy installed. So we can do SciPy, install SciPy here. And also, I like using IPython rather than just the regular Python terminal. So you can install IPython as well. In fact, I think if you install IPython, it naturally installs NumPy and SciPy too. So it might be something where if you just install IPython, you kind of get all these other ones along for the ride. But you can check that yourself. I don't remember doing that. I don't remember if that's true or not. So once that's installed, let's say now we want to do we want to install PlasmaPy. Give it a second here. I think it doesn't like it if I try to open up a, yeah. Okay, so it's installed. So now if I go back to installed, get rid of my search bar, you can see that I have now SciPy and NumPy installed. So I'm going to open up a terminal. Now I want to install PlasmaPy. How would I do that? Well, I would actually, for PlasmaPy, because if I try to search for PlasmaPy on here, I don't believe it comes up. Yeah. I don't really know why. I think that it has to do with just, I mean, this is for the PlasmaPy developers, how they distribute the versions on like PyPI and Conda. I'm not quite sure why this is, and it at this point is it doesn't really matter.
I can mention
yeah,
under channels. Could you click on channels? There should be Conda Forge there. So if you go to add and then type Conda-Forge with a dash in between, that should do magic.
Oh, okay. Thanks, Nick. That was actually quite useful.
That's one thing that
see if it's useful in a second once it actually lists that.
You might also need to update the index, but I don't think so. That might just also take a couple.
Well, it's updating the channel. Let's see what happens. The alternative is, like I said, going back to Eric's analogy, where you can sort of combine these sort of prepackaged meals with sort of, cooking something on your own. I could just as easily go into a terminal and do a pip install Python PlasmaPy. And it would do exactly what Eric showed you earlier. So you can, if there are packages that for example, that aren't necessarily indexed on any one of the channels on PyPI or Conda, anything like that, you can install this. You can also install using directly from GitHub as well. There's ways of doing that. But like, for example, I have my lab has sort of an internal package that I don't have posted on any of the PyPI. So when I want my students to when I want my students to install it, they basically just install it using GitHub, which I don't know if we're going to go through that later on or not, but at any rate, there's different ways of doing that. Oh, look at that. So it looks like as of the updated version of PlasmaPy is only up to 6 on CondaForge. So here's another reason why you may want to do it manually like I did, because this is installing PlasmaPy 8, which is the latest version that just came out.
David, if you have a terminal open, we can't see it.
Oh, yeah, sorry. Let me switch to my share to screen. Now, can you see the terminal?
Yes.
Okay. So I literally, at the very top, just typed in pip install PlasmaPy in my terminal. You can see that I'm in the hack22 environment because right in front of my that very first line, it has in parentheses hack22. So this was exactly the same approach that Eric showed using terminal. And it's taking its sweet time to install PlasmaPy, of course, but I can do that with any of the other systems. And now that Nick pointed out that you can add the CondaForge channel to the channels that the navigator is going to explore, you can find PlasmaPy there. Although again, it doesn't seem to be the latest version. I guess that's it for all sorts of other fun things that installed here. That's it for Anaconda. I think we're going to move on to the IDEs now. Or that's all I have, unless anyone else has any other comments or questions.
I think we have a break now, right? The social hour?
Yeah, I think that's what's next.
Yes.
Yep,
Yay.
10 a.m. Oh, okay. Well, great. I timed it just right. I had no idea, but that works. All right. So we'll reconvene at 2 p.m. Eastern, 11 Pacific.
So the way to open a terminal on a Mac, first go to Finder. So click on the Finder icon. And then once you've clicked on the Finder icon, select Applications. And in the Applications folder, there should be something named Terminal or terminal.app. And if you select that and open it, that will get a terminal for you. Sometimes it will be in a subdirectory called Utilities, and otherwise I think you can search using Finder to get it. So
there is actually, for Macintosh, there is a keyboard shortcut for the utilities. If you have a Finder window open, press Shift Command, which is the Apple key, and U for utilities.
I'm gonna write that down. I'm used to Linux, but I have a...
So that is, once again, Shift, the command, which is the flower-looking key, and capital, that gives you a capital U for utilities.
Awesome. Yeah, that's really helpful. Please continue to share hints. So on Linux, it should be pretty straightforward. If you press and hold Control, Alt, and T, then a terminal should come up for you. One that might end up blocking slides that you're trying to present. The other option is to go to the menu and then search for and select Terminal. All right. Has everyone on a Mac or Linux been able to get to a terminal? All right, I'll post this on the Discord also. Will?
Hey. So on the Windows environment, it's a little bit more complicated, mainly because there's a native shell, which is actually pretty close to being deprecated, and then there's the future shell, and then there are Linux-like environments. So I'm going to just cover some of the options that are available. So, but the focus of what I wanted to show is just, I want to provide an overview of the terminals and how they impact your collaborative development with Git and Git resources. I made sure to stick to that because just like anything, it's very easy to do a deep dive into a lot of stuff, and not all of it is necessarily relevant to what you're doing. But the TLDR is, I really recommend that you install Windows Subsystem Layer, WSL, because it provides a nice Linux platform for collaborative development. And I'll explain why that's my recommendation. Obviously, it's still a personal choice though, so there's definitely arguments against it. Or not really against it, but there may be arguments for some of the other ways of developing. I'm going to jump down here to the bottom. Here are some instructions for setup. You can either work on this as we're going along, or you can also, we were talking about possibly doing a breakout session after we finish with the virtual environments, and we could probably work on this together if anybody is interested. And with that, Eric, would you mind posting the poll on how many Windows users we have?
Just launched.
Awesome. So if you could just answer the poll, I'd appreciate it. Okay, so going through,
much like our debate earlier, there's always more Windows than you expect.
how much are we getting so far?
63%.
Wow, fascinating. Okay, well then I'm glad we're talking about this. Feel free if you disagree with me. I welcome controversy, so that'll make it an exciting discussion. All right, so the native shell for Windows, and it's gone back for many decades, is the command prompt. The command prompt, the appearance of it over here, you can see it works. We'll talk more about why you would use the command prompt, but it is native, and it's still factually the primary shell for Windows. However, Windows 5 years ago introduced, I think it was about 5 years ago, but it may be longer, introduced PowerShell. And I'll just read here. PowerShell is a cross-platform task automation solution. So that's a very important word, task automation solution, made up of a command line shell. It's a scripting language and a configuration management framework. So PowerShell, one of the nice things about PowerShell is that it runs on Windows, Linux, and Mac OS. So, it's nice that you have 65%. Okay, great. Well, we're not wasting people's time. More than half of you care about this. So it's built on the Microsoft.NET technology, which means that it is object-oriented in its nature. So that really influences a lot of what syntax is like in the system, because you're actually sending messages to objects and stuff. Another terminal solution that's available is the Cygwin shell, and this one was really the biggest name in town for a while, because what it did is it provided it's a large collection of GNU and open source tools which provide functionality similar to Linux distribution on Windows. What it does this because it has a dynamic link library, a DLL, which provides substantial POSIX API functionality. And I'll talk a little bit about POSIX later. But the nice thing about POSIX is it interoperability with the kernel is consistent when you have POSIX, when you have a POSIX compliant shell. And then the one thing that I want to say on this is that we call the Cygwin shell and its approach to Linux an emulator. It's a Linux emulator, and it's not what the next one is, which is a virtual machine. So a Linux emulator means that all of the instructions are, the API looks like Linux, but the actual code is implemented underneath the hood with a Windows API or Windows calls. So it's really Windows commands with a layer of Linux API. And it really impacts a lot of your development on this platform, and which can be confusing and sometimes when you have unexpected behavior. So it's important to understand that. And then finally, the one that I'm recommending is Windows sublayer, subsystem for Linux, which just came out a couple of years ago, and it's been released to the general public this year in pretty widely distributed. Basically, it's a virtual machine, and it is a virtual machine that is running Linux, including all of the command line tools, utilities, and application. It's running directly on Windows, unmodified, without the overhead of a traditional virtual machine, or a dual boot setup. So, sometimes you want to, back in the day, you would, if you wanted Linux, you'd switch and launch Linux, or you'd switch and run Windows. But now you basically just launch this virtual machine. And I'll tell you some of the advantages of it. I had the second link here, I put in there for any of you geeks that want to go and do a deep dive on some of the feature differences. And surprisingly, I know most of these. So, yeah, so you can see variables and expressions there's differences. Sometimes there is not even a feature in one of the platforms. Arithmetic and logic, I find this surprising, but command.exe, the native shell, doesn't have booleans or conditional expressions. So if you want to test whether a file exists before you actually trigger a set of instructions, you really can't do that in command, but you can do that in POSIX shells or PowerShells. So anyway, I don't want to go into detail on a lot of these regular expression syntax, date and time, arrays, but it's available. And it actually, if we have a discussion later, I don't mind talking about it offline, but I don't want to use up too much time. What I did do is summarize the features that I think are really important. So the most important feature for us is these sets, and all of the shells have this capability. So you have command line get support. All of them have it. Secure shell capability. All of them have it. And Python environment, all of them have it. Now you have to install it. Actually, to be honest, you have to install it on all of them. But we've already talked about how to do Python. We will talk about how to do Git and other environments, but these four options represent choices that you can make if you choose, but there are subtleties and nuances on all of these. All right, so feature comparison. The nice thing about Command Prompt and PowerShell is they're pre-installed, whereas Cygwin and WSL are not pre-installed. Similarly, the command prompts in PowerShell both use the native Windows file system, and that offers some advantages, and I've utilized that sometimes. Whereas Cygwin and WSL, they can talk to the file system, and that's really one of the beauties, is that you can navigate the Windows file system from the command line, but the file system that is native to them is different, especially WSL. WSL is really a Linux file system, and that really is important, but it plays nicely with Windows. Simple Unix-like commands. Command prompt is not Unix-like whatsoever. I shouldn't say whatsoever. I mean, you can CD to directories, but that's about it. PowerShell contains most of the simple commands, which Nick reminded me we probably should talk about. So we can talk about that later. Cygwin and WSL have the full suite of Linux API. The last three, PowerShell, Cygwin, and WSL, are the ones that have robust command line history. If you close the command prompt and then you go back and you try to recall previous commands, you can't recall it in command prompt. It doesn't retain a history. Whereas in PowerShell and Cygwin and WSL, if you hit the up arrow, you can navigate through previous commands. Tab completion and command prediction, all three of the other ones have that. So, if you start typing, you do CD, and then you might type the full, type the path. If you hit tab, you can complete the navigation. And if the path is unique, you can navigate all the way down to the file without having to type anything but tab. Supporting aliases, configuration of your environment. All three of these are configurable, so you can personalize commands that you use frequently, whereas you can't really do that in command prompts. Okay, this one's important. Full Linux recipes. Only WSL will allow you to use full Linux recipes. So anything that you see online, obviously there are differences between Linux flavors. And so, something on Ubuntu may not necessarily work as well with like a Red Hat or whatever. Or I guess it's not Red Hat, but whatever the flavor. I'm not a Linux expert, but there are different flavors of Linux, and sometimes you can have, and there's even different flavors of shells within Linux. So you also have to know that. I saw somebody talking about corn shell or K shell earlier. That brought memories. Right now, the primary shell is Bash. That's what most people use. Although on the Mac, is it T shell, TCSH?
Z shell now.
Oh, it's Z shell now. That's right. So it's Z shell. Z shell. When you talk about the various shells, even if you say something is Linux, there are facilities inside of the shell, like different types of shells. I didn't get into that in this, but we can have a discussion if we'd like at some point on it. POSIX compliance. The only one that's fully compliant would be WSL. This Cygwin is almost fully POSIX compliant, and PowerShell did as much POSIX compliance as they could. But POSIX compliance has to do with how you pass arguments, and well, one of the features of POSIX compliance is how you pass arguments into your executables. So, your command line arguments, argv. I know Eric has an example of using argv. Using argv or arg are actually POSIX protocols, and so POSIX compliance is one of those things. As I was doing study preparing for this discussion, I realized that there really isn't anything that's 100% POSIX compliant. It's a very complicated standard, and to satisfy it is difficult. But the best one on Windows is WSL. Runs X11 GUI apps. Most people think that one of the GUIs one of the applications that people will tend to want to open is inedit, because they want to open a text, they want to edit a text shell, a text file. And you can install inedit on Windows if you want to. But with Cygwin, you have to actually install an X11 server because it doesn't have an X11 server natively. So an X11 server is really what tells Windows how to bring up a window on your desktop. And each operating system has its own windowing system. So Mac uses, back in the day, Mac used to use I forget Mac's windowing system, but it's different than Windows's windowing system. But the one for Unix and Linux environments is X11, and only WSL has the nice thing is WSL is Microsoft's virtual machine, and it has a built-in X11 server, so you don't have to do anything to access it. You just install it. Then you have redirecting through pipes. These three can redirect. This one can kind of redirect, but it's confusing to me. And console help and a rich package manager. This is very important. Package managers, we looked at Anaconda today, but Anaconda is an example of a package manager. Pip talks to package managers. All the Linux packages you can access. So basically, if you want to install an app in Linux, you can go to the web and find out how to install it, like Laypack or BLAS or any of the libraries that are common. Those are, I think I'm thinking of Fortran, but anyway, those are all the feature comparisons that I thought were pertinent for our time. And like I said, you can go back to this hyperglot and look in detail if you'd like. But yeah, here are the instructions on how to install WSL. And this will be install and configure. And like I said, we're probably going to set aside some time after we're done with these discussions to go through that if you'd like to just do it together as a group. But we won't take time for this discussion for that. And that's all I have.
Thank you, Will. And Nick?
Sure.
Are there any questions? All right, Nick, were you going to say some? Otherwise, I was going to lead into the IDEs.
One quick thing, I'll put a link in the chat to, which has 16 must-know bash commands for data scientists. And if you're learning the Unix shell, this is a good article to go through. It includes things like how to navigate directories and things like that. There are different flavors of Unix shell. So there's bash, KSH and ZSH and so on. Most of these commands will be the same in all of them since they're pretty fundamental. So yeah, I highly recommend going to that.
Nick, do you have that in the Unix shell write-up you have?
I do.
Okay. Excellent. So you guys can always go back and find that in the resources directory. All right, any other questions? All righty, I'm going to lead into interactive development environments, or IDEs, basically a fancy name for fancy code editors. Okay, so what is an IDE? As I said, it's basically a code editor, but it's a fancy place that incorporates a lot of the tools that we need in order to code productively. So IDEs generally incorporate some kind of, like I said, source editor, some kind of compiler, debuggers, terminals. They often will have additional features like test runners, so you can run tests on your code. Some have Git integration, which we'll cover more tomorrow, as well as GitHub integration. Again, we'll cover that in more detail tomorrow. And they also have code inspectors and linters. They will often, for example, Python style guide is referred to as PEP8, and it has a bunch of rules on how you should, what kind of syntax or variable naming schemes and stuff like that you should be using for your code. And a lot of these editors have this kind of rule book built in, so it will let you know as you're coding if your code is up to PEP8 standards. So in my experience today, there's 3 predominant IDEs that people use: Spider, PyCharm, and VS Code. And so we're going to cover all 3 in a little more detail following this. I find that choosing your IDE is really a personal preference type thing. So we kind of want to give you an overview. So if you haven't already selected one, it gives you a little bit more information so you can choose one to run with, because you'll definitely want to have selected one for activities tomorrow and Wednesday, Thursday, and Friday. So Spider, I don't think there's a parent company for it. It's just an open source platform. PyCharm is provided by a company called JetBrains. They produce a ton of other IDEs for different languages. And then VS Code, which is also very popular, is produced by Microsoft. All 3 versions are open source, with a caveat with PyCharm. PyCharm has open source versions, and then they have license-based versions that you have to pay for. Again, so that leads into the next one. All are free, with a caveat on PyCharm. It has free versions and paid-for versions. They all have the basic tools of code editor, built-in terminal, built-in debuggers. However, Spider does not have built-in Git or GitHub, whereas PyCharm and VS Code do. However, all 3 are extendable, and that is there are plugins that you can download and add to your editor to increase its functionality. Okay, so I just wanted to give a brief overview. Are there any questions before I hand it off to the next person? All right, so I will hand it off to Steve and David for Spider, and then Will and Ramiz for VS Code, and then I'll come back to cover PyCharm. All right.
Oh, so I don't know where David is. Oh. David, you wanted me to start off?
Sure, because I mean, I can show what I do, and then, or you can start, whichever.
I'll show some basics, and then David will
I'll jump
figure
in.
out what I forgot to say. So let's see.
Well, while Steve is doing that, I will mention that, like I showed with the Anaconda navigator, you can launch Spider or VS Code for that matter, directly from your Anaconda navigator, and you can specify which environment you want to launch it in. So you can have different iterations of Spider or VS Code or whatever IDE you want for each environment. So in general, if you're using Anaconda, you don't need to go through the process of separately downloading it. You have to install it, but sort of Anaconda has prepped you to be able to install it very easily. But you could also, if you're not using Anaconda, you also can just go to, as Steve has up here, the main Spider website.
Yeah, okay, thanks, David. Let's see. So I'm going to post, let's see. Well, so again, back on the PlasmaPy Hack Week resource pages, if you go there, let's see. So this is just the PlasmaPy Hack Week repo. If you look in the resources directory, you'll see a markdown file for the IDE for Spider. It's very basic, but it tells you just how to get started with it. So the most important things are how to download it, how to install. Like Eric had mentioned, there's no direct integration with Git and GitHub, but you can do it through some with a third-party tool called GitK, which I don't use, but at this point, we just want to get you familiar with, is this something you want to, is this one of the ones that you want to use? So if you click this link for visiting the Spider download page, it takes you, let's see, so it really takes you to the main page is up on top. Gives you a little overview of what the development environment looks like. We'll get to that in detail. So what it really consists of are, as Eric had pointed out, this one has an editor. It has a built-in IPython console. It has something called the Variable Explorer, which is useful if you're coding, you're running your code, and it will spit out a list of everything that's in memory and allow you to have a look at it. So we'll have a look at that. You can do plotting inside another window within the IDE, or you can do it with pop-up windows. It does have built-in debugging capability and help for if you forgot what those command, the order of those specific commands should be in the arguments should be in the functions. It has a few plugins. If you're interested, check those out. But really the most important thing, if you don't have it, and this is something you want, go to the download page. And they have extensive installation instructions. So first of all, automatically will detect which browser what operating system you're using. So it knows I'm working on a Mac right now. I use Spider with Mac and Linux. So no PC here. Sorry, guys and girls. So it's offering me this download for Mac OS, but it hopefully will detect what OS you're using and give you serve you up the right one. If not, again, in the download and installations section here, it has an extensive troubleshooting. So if things go wrong, I think it gives you 3 different ways to try to fix it. The preferred method, the way I did, I think, is to use the standalone installer for your OS. That's the easiest way. You just grab it. I think for Mac, it just opens up it mounts a virtual drive and you drag it into your applications folder and there it will be. You can do it with Anaconda. So some of the ways that David was showing you earlier, and it has the more detailed, if things go wrong kind of thing for Windows, Mac, and Linux. If you don't want to try any of those, but you just want to poke around and play with it a little bit, that actually has an online version that you can try out. And they set up a binder environment where you can just look at it, so you can get to that through the link there as well. If anybody has any questions, I made my font really big so that I'm not looking at the chat right now. So if I think there's one question. Okay. All right, that's just Eric. We'll ignore him. So let's see. Yeah, they have detailed instructions for if things really go wrong, but hopefully that's not going to happen. So follow through. Try the standalone installers first, and then work your way down for alternate methods should something go wrong. Or ask us, especially in the Discord channel, or there's online help on Discord or in the chat here. So assuming let's assume you get it all installed. Like for me, it's in my applications directory. Also, I've put a link on it into my dock here. So I'm just going to click the Spider IDE icon. let it bounce around for a couple times, and let it start up. Takes it a moment.
As of right now, we're still just seeing the web browser.
Yeah, it's still starting something up. So yeah, it's not doing anything. Don't worry.
Okay.
There we go. You see that?
Still just the web browser.
Hold on.
My guess is that you shared just the web browser rather than your entire desktop.
So let me give the, it's still loading some things up. So once there's an actual window there that I can share. Okay. Let's try sharing. All right. So this just popped up. It always wants to open something. It always wants to complain about something. I just ignore it. Okay. So this is the main parts of the IDE. On the left-hand side, you see somewhere you can edit your text. It always wants to serve you up some kind of file right away. So it always create an untitled and then a number.py file for you to work on. Creates a little doc string. That's the green stuff here behind the triple quotes. So it does color coding there of everything, and will pop up your username from wherever you started it as. In the lower left, it does often, sometimes the terminal works, sometimes it doesn't. I'm not sure why. So if you have that issue, we'll have to work on it together. It has a history of things that you've done for a while. So it has this persistent history that Will talked about. It goes back across various different instances of Python, of Spider that has been run. But most importantly, it has an IPython console for you to type in on-the-go commands instead of running a program. And let me start with the basic kind of unit of programming, or the over level that Spider likes to work with is called a project. You can get really complicated projects, you can have really simple projects, but it's helpful if you're working on, let's say, the analysis of some kind of data. You have your data files around and you have the code that you want to work on it with. It's helpful to make a project out of it. I made a project for this demo. I'm going to load that up right now. So you might not be able to see because the Mac keeps the Windows, keeps my window disconnected from my drop-down window. So I'm just going to load a project. So the menu option may not be visible right now, but there's an upper level project menu that I can just open. Project that I created earlier. Hold on. Okay, so it popped up another little tab window pane on the left, which is called Hack Demo. So this is the project viewer. So it looks like a file browser. So it has this demo.py file, which is the one I'm editing right here in the code editor. So one cute thing it had that I think Python, the Spider IDE has that I'm not sure other IDEs, Eric, maybe you can mention if PyCharm has this, is it allows you to divide the code into different cells. So you can run one different cell, or you can work on different cells that it's one after the other. So it's helpful if you're debugging something, you don't have to run your entire script. So by default, the first thing is just, your entire code would just be in one cell. But then if you add this hashtag and 2% signs, and then you can add a label to it, like this is a cell that I have here on line 13. You can see that it also has the line numbering here. This is great if you want to have, when you get into an error, it's going to tell you where it is, and you just go to that part of the code. But every time you add another hashtag and then 2% signs and some kind of name, it creates a different cell that you can work on. So I've created 2 other cells besides the main one. So in the top one, has this, when I created it, I made it yesterday. I'm the person who made it. You can put your import strings up here. And then you can also, you can run the entire script by pressing this play button. You can run the current cell. You can run the current cell and move to the next one. Or you can run the selection of the current line. So I can just select this top cell just by putting my cursor in there. It run this and move to the next one. So it ran cell 0. It doesn't have a label right now. And then it's in the second cell labeled this is a cell, which it does some variable assignment. So if I actually run this, this cell, it makes 2 variable assignments. And then in the upper right-hand portion, you'll see this variable explorer now is populated by two variables. X, it's an integer, it's a size 1, meaning it's a scalar, and it has a value of 2. So these are the assignments that I've made. So as you make variables, they will all populate in here, and you can scroll around and see them. You can sort them by the name, what type they are, what size they are, whatever is convenient for you. And if I run, let's see, and if I try to run the next cell, well, I've already labeled this as this cell has a problem, and you can see on line number 19 it has this red X in it, and on the strip on the right it has a little vertical red line where an error occurs. So if you have a really long code, you'll see where all your errors of code also labels, import SciPy as SP. I don't know. This should come up as a warning because I've been actually, I don't know why. Sometimes we'll pop these things up as warnings and mark them as orange. We usually do that. It tells you you've imported something but haven't used it already. Anyway, so this helps me identify things. So if something goes wrong, I can go over here. Oh, I'm actually in a, if you click the red dot, it says, oh, you cannot assign to a literal. Oh, okay. Whoops, I meant to hit something like B instead of 2. Okay, and now maybe it's taking a while to catch up. Okay. Should go away. I should be able to run this part now. Yeah, so it's made A and B. Hopefully this red dot goes away. So it's made 2 new variables. It's labeled the, it tells me the of arrays of floats type float 64. So that's great. Now, okay. Oh, now it's telling me. I guess the code analysis is not keeping up in real time. So other little warnings show up with triangles that says, I've imported it, but I haven't used it. Okay, that's fine, but it's not going to stop me from running my code. And somebody was asking earlier about, how do I remember what variable goes where? In Spider, you can use the help tab here. It says you can get help on any object by pressing Command I in front of it. So either in the editor or in the console. So let's say if I'm unfamiliar with NumPy's linspace function, I'm supposed to be able to hit Command I, not that one, and retrieving documentation should give me the whole documentation for what linspace is. So it should be I should be able to go from some stop to some start with some number of steps, which is what I put in here. So go from 0 to 5 in 26 steps. So that's why it spits me back in the variable explorer, this array. And also, if I hover my cursor over it, I have another program called Kite, which I think it's installed with Spider that does some of this automatically. So those, anyway, that's the kind of rough overview of what NID, or especially this one, looks like. Some annoying things pop up now and again. David or Eric, is there anything in this particular ID that I should be pointing out that it does or doesn't do?
I think the one thing that I have found useful that I discovered recently, if you go to the little Python symbol up by the directory in the top right corner, go right, that guy there.
Yeah, this is the
That
path
allows
manager.
you to append your Python path dynamic. Like you can put in new file paths, directory paths, and you can turn them on and off, and it becomes available in your Python console.
Is that, did you just say the Python path variable right there? Yeah,
Yeah.
I was gonna say exactly the same thing. I actually find, well, one, I have to say I just learned a whole bunch of new things about Spider, despite using Spider for pretty much the entirety of my Python programming experience. That tells you how inquisitive I am about the stuff that I use. But one thing that I think Eric was alluding to is your pathways, and that when you, and I think this is generally true of IDEs, you need to at some level determine where your IDE is going to look for code. So particularly as you start having say your own your own self-written code or whatever functions that you've used, you need to make sure that the IDE knows to look in those folders for certain things. It already knows to look for your modules that you've installed, like NumPy and SciPy, etc. But if there are other places, if it's referencing other modules or other things, you need to, I found that with Spider, you need to explicitly tell it where to look. Now, there's one issue that I tend to notice that it doesn't tend to look in folders. So if you tell it the folder to look in a folder and it's actually in a deeper folder somewhere in the hierarchy, it doesn't natively do that. Maybe I have an older version. I actually haven't updated to 5 yet. I think I'm still on 4. But I've had issue there. But usually if it can't find something, it's just a matter of making sure that your path is correct, or that you have the proper path set up. So anyway, that's just one detail with Spider that I've encountered myself. But other than that, I think Steve covered more than I could have covered, certainly.
Okay. I didn't know about cells until this weekend.
Well, we can see who did their homework then, Steve.
I didn't run, I was reading about all the buttons to press, run it. It said running your entire program is that button is probably the least used. That's the one I use all the time.
That's the only button I've ever used. Now I only just recently discovered that you can highlight a section of the code and then run that code.
Wow.
But I literally found that out like a few weeks ago. But now obviously that the intent is to actually do that with these cells.
Those are all MATLAB features that they borrowed, which is smart.
Yeah.
Still shamelessly.
One thing, I guess, when whoever talks about VS Code, a downside with Spider is it doesn't as easily switch between environments. At least that maybe there is functionality in there, but whereas I know in other IDEs it's a lot easier to go between different environments, although that's typically more of an advanced thing that you'd be doing. But
all right, well, thank you, Steve and David. Are there any last questions? All right, I figured I'll hand this off to Will and Ramiz, and they will be covering VS Code.
Sounds good. So I'll kick it off, and then Ramiz, you can kick in whatever I miss, which will probably be a lot. But Okay, so we'll talk a little bit about VS Code. So VS Code is Microsoft's latest text editor. And it's so funny because originally when it started, it really was a text editor. And then slowly but surely, they started adding all this plugin feature capability. And literally, you can turn it into a full-fledged IDE. And it's really beautiful. The nice thing is it's also available on multiple platforms. So you can run VS Code on VS Code on the Mac. You can run VS Code. You can run VS Code on a Linux as well, right? Anybody? I haven't actually done it, so
It seems like blasphemy.
Yeah, you can. You can use it on
Nice thing is-
Linux. I have used it, so yeah.
use it on Linux. Okay. Okay, Pavel and John both agree too. So yeah, so it's pretty nice that you can do it. Oh, that's right. I have used it on Linux myself. Now that I think about it, on Princeton's Linux servers. So anyway, that's really nice. Some of the things that I want to highlight, you have a navigation editor over here, and it will show you the full list of files that you're working with. You can see down here, you may not be able to see, I apologize, I don't know how to make my screen bigger, but there, right here, we have Git integration. So with the Git integration, right now, if you can read it, it's saying that I'm currently on unstable. So the directory I've opened, file, open folder, OMFit source, for you OMFit people. This is all the source code for OMFit, and currently this is a Git managed repository. And so it recognizes the Git management and says that I'm currently operating on unstable branch. Up here, I can navigate to other branches through the branch navigation. And I had one that I was going to use for just showing. I don't want to do one that's too complicated. I lost which one I wanted to use, but we'll switch to that branch. When you switch to the branches, you don't really see too much that changes, but yeah, that branch doesn't have, that branch is up to date. There, TK paste mods. You can see up here on the left side, there are different plugins that I have, and one of them obviously is the source control. So you can see with this, the commit logs and changes that haven't been pushed back to Git. And we're going to talk more about this tomorrow in detail, but it's pretty nice that you can see your changes. It also has a terminal integration. So down here, you can look at your terminal, navigate, you can execute commands.
Hey, Will.
Yeah.
The terminal you have up right now is WSL?
Correct.
Now, I'm assuming the answer to this is yes, but are you able to configure which terminal is your default one for this? So
yes.
you wanted PowerShell?
You can switch it to PowerShell. You can switch it to command if you want. You have a great degree of flexibility in what shell you operate in. But like I said, I typically stick to WSL. It has debug features built into it. So if we open up within OMFit, this is, where is OMFit? Right here. Oh, there we go. Look at that. I just did Control Plus and it increased the font size, so we can actually see it. But you can come in here and put a debug breakpoint somewhere in code, and you can run the script. Since there's a real convergence in IDEs, to be honest with you. I was just looking at Steve's presentation on Spider, and a lot of the features. I don't know about cells within here, but there are a lot of features that are universal. There is one thing that this editor offers that others that, like for instance, Spider doesn't offer, and also PyCharm doesn't offer. So got to showcase the unique ones. Let's go here to so over here I have a shell. Okay, I can launch the shell from the command line. So when you just say code dot, that'll open it within this directory. And when you open it in this directory, these are all Fortran files. I'm not going to mess with anything right now. I'll deal with that later. So with the Fortran files, it has the ability of editing modern Fortran. It can do breakpoints. It can navigate you to you can go to where the variable is defined. So if you're somewhere inside of the code and you want to go to the definition of a particular parameter, you can navigate to the definition. So a lot of the features that you would expect from a modern IDE, you get inside of VS Code. Somebody commented, oh yeah, there's Jupyter integration within it as well. That's correct. So trying to see, yeah, so you can see over here, go to symbol in editor, go to definition, go to declaration, go to type definition. These are all very useful navigation features when you're editing, and it can really make coding much more pleasant than having to do Control F or Control Shift F to be able to search through your entire project. You know, there's, you know, let the computer go to it for you, going to line number. So it's very feature rich, and like I said, one of the biggest advantages of VS Code is the rich package. So let's say you want to look for all the packages. I haven't installed something with git blame. I don't know what this one does, but somebody thought a package related to git blame would be valuable. I mean, I know what git blame does, but I don't know. We'll probably talk about blame. Eric, will we talk about blame tomorrow?
I can mention it.
Yeah,
I wasn't planning to, but I can.
Blaming is a nice way to see what other people have done. But my point in showing you this is not to say what features you need, but to say that you have a rich set of features. One thing to note about code, though, this is really good. If you look here, you'll see it said on this particular module, it says install in WSL Ubuntu. So VS Code is actually running in Windows, and it's talking to WSL, the Linux virtual machine, through a remote session. And the nice thing about remote sessions is that anything that implements SSH, which we'll talk about, it can actually launch a remote shell to that thing. So oftentimes, for instance, I'm working on my local machine. I can open files that are on a different server and work on that. So, you know, we have some servers here at General Atomics, that I'll navigate to, and I'll navigate through the SSH features, or the remote connection features. And I feel like there was more that I wanted to share. I guess I can share, it's configurable. There are a lot of different settings that you can set within it. Get credit. Nick says, I'd rather call it get credit than get blame. I like that. That's so positive, Nick.
I'm curious, what is the scenario that makes you usually go look for the get blame?
For me, it's super useful. So there's lines of code that I'm trying to figure out who and when it was edited. So, it's gone through changelog. And if you go and look at blame, you can actually go through the tree, the timeline. And within the particular line, it traces. I can pull it up with OMFit source with some source code maybe tomorrow.
I was just curious what scenario generally made you go search for it. I know for me, I tend to go to it whenever we have a continuous integration failing on GitHub. I'm like, why is this not working anymore? It's working tomorrow. Turns out someone released the new version, and I have to go find out what that was and when it happened.
Oh, that's a new one.
So in that case, instead of get credit, can we call it get fault? The reason why all the CIs break? Never mind.
Well, get blame. That's why usually you don't go there because you're happy about what they did.
Ah, I get it.
So one other thing I did want to show. I'll probably get to show this tomorrow, but you can also look at the I'm going to find it here. I might have to show it tomorrow because I can't find it. Down here is where you manage what environment you're on. Down on the right corner. So I clicked on that button right there, and it lets you navigate through your various environments. Right now, it's auto-detected that I'm in a folder that's primarily Python. The line feeds at the end, you can select what kind of line feeds. Most everybody uses Unix line feeds. The encoding is UTF-8. The indentation spaces is 4. Here's the line numbers and column numbers, that you can see while you're editing. See which line number you're on, things like that. I put a lot of information. Can you show, or Eric, can you put the link in there for the resources so people can go to the resource?
Do you want the directly to the markdown?
It should be in the markdown. One of the things that I was going to show in the markdown that is stored on the resources GitHub link, I have a link here to intro videos. And the nice thing is, because it's Microsoft, they put a lot of money into supporting it. And so they have all kinds of videos on managing, tips and tricks, user interface, themes. If you don't like the theme, you can switch themes. If you don't like the key bindings, you can personalize your key bindings, et cetera, et cetera. Thank you, Eric. Ramiz, you want to say anything?
Just two very minor things. One is that you can use the whole VS Code setup as Vim if you prefer that. So that it works with every shortcut that Vim has. And you just go to the settings and modify it, make the changes so that you can use the editor as Vim editor if you prefer it that way. Another thing is, yeah, just do control comma, and I think text editor here, right? Somewhere there, I think you can use it. I forgot exactly where it is, but you can search for Vim and it will let you do that.
What's the name? Maybe the nice thing is we can search our features.
Right, I think it's if you just say search for Vim, it will let you do that. One of the place you will see an option to what do you call it?
Did you say Vim?
Vim, V-I-M.
Yep.
Yeah, so you can just I believe there's a checkbox somewhere which lets you do that. I haven't done this in a while, so I don't remember where exactly it is.
Is it built in by default or is it a plugin?
Oh, it might be a plugin. You're right. Right. Yeah. So I guess.
Oh, so if you want VS Code to work like a Vim editor, then you can install a plugin that will enable those features and switch over to it.
Right. Yeah. I guess I should have mentioned that you need a plugin, extra plugin for that. Another thing is that generally when you have VS Code open or any IDE open, you would have a bunch of files open. And once you close it, you lose all the files which were open. But what you can do is you can close it right now. And then if you go and open up the same folder, the next time it will remember what files were open and it will reopen those files. And that is very handy if you're working on multiple projects and you don't want VS Code to use all the resources which are there. So in here, as we'll open the folder, it reopen the OMFit dependencies and settings because those were the two tabs which were already open. So that's really good. Another thing is with this is the use of GitHub Copilot, which I think I will talk a bit more about later this week. So we will cover it then. But yeah, that's kind of the only thing I wanted to add to what we'll have there.
Awesome, thank you.
All right. Thank you, Will. Thank you, Rameez. Any last questions? Okie dokie. I am going to.
Oh, sorry. I will just add this. You can use the whole VS Code for LaTeX files. And that's what I mostly use these days. So instead of using any of the other LaTeX thing, it's not strictly related to PlasmaPy, but I'm guessing a lot of people here use LaTeX. So you can use that for LaTeX editor as well. You need to have plugins, but yeah.
Yeah, but it's a good argument on why to use VS Code over other options like PyCharm.
I believe PyCharm has LaTeX integration. I've never explored it, so I can't say that for sure. Anyways, as you can probably tell, IDEs are very much a personal choice. All right, so I put into the chat a link to the Markdown document that I'm using to summarize PyCharm. So as I've mentioned, the most common IDEs that we see are Spider, VS Code, which you've seen now, and then PyCharm. PyCharm is the one that I essentially use, and as we go through this hack week, every person gets to use whatever IDE they prefer. So PyCharm is a Python-centric code editor. IDE, but that doesn't mean it can't do other codes. It recognizes other languages, and you can still edit other languages in PyCharm. It's just the editor is Python centric. And the company JetBrains that makes PyCharms, they also make language specific IDEs for several different languages. As I mentioned earlier, there is both a free open source version as well as a pay for professional version. Both of them can be downloaded directly from PyCharm's website. Usually everything that's in the free version is all you need. There are a couple features here and there that are only offered in professional version. It's been a while since I looked at it, but probably the most common one would be SSH capability. I believe that's only available in the paid for professional version. However, they do offer an educational version. So I put a link in the write-up that links to a place where you can apply for an educational license. This is free for students and teachers. So you just submit it, and they'll give you a license, and it will activate most of the professional features for you. Okay, I think that's a quick summary. I've also in this markdown, I've added links to both PyCharm's YouTube, their basic tour. They also have a playlist set up for PyCharm to walk through a lot of the features. So I also link that here. So if you want to, you can go explore that in more depth. Okie dokie. All right, now I'm going to walk through PyCharm itself. Can everyone see this all right? Okay, I'm going to assume yes. Sorry, y'all. Getting myself organized here. All right, so what you see here, I have PlasmaPy open in a session in PyCharm. Now, both PyCharm and VS Code tend to be package centric, whereas I feel like Spider is still kind of script centric. So as scientists, we've always been used to the idea of writing up our code in a script and running it to get the job done. Whereas in open source development, it's not so much about writing a script that gets run. It's about writing a package full of tools that lets you do other things. And so in PyCharm, so I have PlasmaPy open here. And so on the left side, you have this project pane, and this shows the breakdown of the file structure of the PlasmaPy project. Can everyone see this all right? The font's not too small?
No, it's okay.
Awesome. But in the most recent release of PyCharm, they have introduced what's called a light mode. So you can open a script directly from your file system, and it will just pop up as a simple text editor or code editor. So they do have a light mode now. Okay. I've always found the biggest challenge with PyCharm is actually getting this set up as you like. So if you go to the settings, the very first thing you always need to set up is the Python interpreter for your project. So you always have this setting for the project you're working on, and then you have an interpreter. Can you all see you can see this interpreter window?
Yes.
Okay, excellent. So I've already configured several interpreters here. Interpreter is basically some kind of Python environment. So it could be the Python environment that's default to your system. It can be a virtual environment, which Ramiz and Ronaldo will discuss after this. And so here I already have several virtual environments set up. So these are the Python environments that will be utilized throughout the functionality within PyCharm. They also give you the ability to create new virtual environments on the fly using a GUI. So you can create one using Conda, you can create one using the built-in virtual environment package for Python. So as of right now, my default, what I call is Pi 310 PlasmaPy. So this is my Python 310 development environment for PlasmaPy. And so you'll see down here in the bottom, in the bottom right corner here, this is where I can select between the different virtual environments. And we'll, like I said, we'll cover virtual environments a little more after I do this walkthrough. Okay, so in here, we also have terminals. So as you saw in Will's VS Code, his defaulted to WSL. Mine has defaulted to PowerShell. Okay, and it automatically get the virtual environment for Python 310. My development environment is automatically activated. So whatever I have that set up as is now available for me here. Same thing happens in the Python console. So this is just another instance of IPython. But when you start this, it gets started in this virtual environment, and it automatically appends your Python path to your package directory. So unlike Spider, where you have to go in and manually put in the Python path, or the path to the package you're working on, in this case, PyCharm automatically adds it. So everything will become available. So for example, if I go back to the terminal, I don't have PlasmaPy installed in this environment. So if I do pip show PlasmaPy, it's not installed in my virtual environment. However, in the Python console, because my Python path is appended, I can still import PlasmaPy. Okay, PlasmaPy. And so if I look at the version, so now you've seen us talking about version 8.1. That's the latest release. I'm working on a development branch now. So this is a development version. Now, in here, you also have what you call, you can see what variables have been defined here. So if I say b equals b, it keeps a catalog of the variables. Much like the other editors, you also have a history. So you can go back and you have a history of all the stuff that you've recently done. And you can go back and you can select it, and you can actually combine history methods. So if I want to import sys and print out sys path at the same time, I can select both, paste it, and they show me the current Python path.
I just learned something. That was awesome. Thank you, Eric.
Yeah, no problem. Any questions at the moment? Tell me if I'm going a little fast, and I'll try to slow down a little bit. All right, so the next thing I want to talk about is the code editor up here. So like I said, this is the PlasmaPy structure here. The actual package is in this subdirectory, and I'm going to go into the formulary, and I'm going to open up the module about speeds. So now this is the module, for our speed functionality. This is where alphane speed is defined, ion sound speed, and so forth. What's nice about this is it provides a lot of code inspection. Let's not complain about this. So like Steve showed in Spider, you have these little flags on the right side that tell you, so these are kind of orangey flags. So these are all just soft warnings. So most of them here are PEP8 warnings. Let's see this one. Yeah, for example, this one here, it's complaining about T. And it's complaining about T because on the PEP 8 standards, no variable should be capitalized. It's supposed to be lowercase with the underscore spaces. So it's just telling me that it's not formatted correctly. They will also have the list error. So let's say if I do from PlasmaPy dot formulary import, let's say dot, I think this might actually create an error. Parameters import beta. Oh no, I think I believe I have the code inspection turned off for this. So typically this would show me red squiggles, an error because the interpreter can't tell it's there. But I have specifically modified my settings for my interpreter to ignore imports from that package. And so you can configure these warnings to however you like. You can also, you can split. So you can have it in multiple columns. You can split horizontally. You can split vertically. What else? Speed example, Pepe can be configured. All right. I think that highlights the code editor. Okay. So one thing that I really like about PyCharm, I've never been a command line person. I can never remember what to type out. And so with PyCharm, it has version control built into it. It can handle all the different types of version control software out there. This package is set up with Git. So I have all the version control commands here so that I don't have to remember the syntax for the command line. I can just make a change. Let's say I just, let's say I don't want this line of code anymore and I delete it. And I can go, so now it's complete. Now I got a red flag because I deleted something. So I deleted this alias thing, but I'm using it later on. So it's showing me that I have an error. But let's say I wanted to, so I could actually commit it. I probably shouldn't do this part yet. We'll go over the committing and Git integration a little more, a lot more tomorrow. But it has, you can do it all through a GUI interface instead of a command line interface. You also have this Git tab down here, which allows you to interact with Git controls as well. It also has, if you go to settings, it has GitHub integration. GitHub. So it has GitHub integration as well, so you can attach it to your account. And this will allow you to, it will allow PyCharm to communicate to your GitHub account with your credentials. I think that's all and again, we'll cover that in more detail tomorrow. There's also built-in debuggers and test runners. So in PlasmaPy, we have a lot of tests. So if I open this test specifically for speeds, we have a lot of code in here to test what we've written. And you can run these tests. It has built-in runners, so you can run and see what's passing and what's not passing. And much like VS Code and Spider, it does have a plugin ecosystem as well. If you go to settings, plugins, you have this plugins, and you can search and you go to Marketplace and you can find plugins as well. I don't know, I've never checked. It looks like they do have a Vim plugin too, so you might be able to make it act like Vim as well. All right.
Really, why would you do that?
Say that again?
I feel like starting a war right now.
All righty, I breezed through that rather quick, but I think that's a decent summary of PyCharm at the moment. like I said, we'll be using these throughout the week, so you'll see it more often. And please ask questions about it. And I will stick on today as well to help anybody get it set up, installed and set up if they like. So any questions? All right, with that, I will go ahead and pass the baton on to Ramiz and Ronaldo. They will be discussing virtual environments.
Hi everyone. Am I audible?
Yeah, you're good.
You're good.
I don't know why it's not showing my background, but I guess it doesn't matter now. Okay, so I'll share my screen now. Is it visible? I guess it is, right? So
yes, it is.
Okay, let's see. So this is going to be sort of a lightweight tutorial because I don't want to go much into depth with this because it might kind of get sort of complicated. But let's have a look at this document that you can find in the repository. You go just to the Hagwig repo and then resources and then virtual environments, and you can follow along. And we made sure to include the Unix and Windows versions of the commands. So if you're on Windows, that probably most of you are, you can just follow along using this as well. But I will cover the Unix version because I'm on Mac, so I cannot use the Windows version during the tutorial. But if you have any questions about Windows, feel free to interrupt me at any time during the tutorial because I already tried doing the same setup in Windows and it worked, except for the last part. I had some trouble and I troubleshoot it eventually, but yeah, just feel free to interrupt me whether it's Unix or Windows. So okay, what is a virtual environment?
Can I make one comment on that?
Yeah.
When you say Windows, do you mean command line or do you mean WSL, a PowerShell?
Yeah, PowerShell. Mm-hmm.
Okay. Yeah, because I just want to make sure, because we had that session earlier, that people are clear that it's a PowerShell, not the WSL, because the WSL will look like your Linux instructions.
Okay. Yeah. So in Windows, I guess you have at the bottom some options for searching your applications, and then there you can write just PowerShell, and you will be able to open your PowerShell terminal. Well, on Mac, you can use Command space and search for the terminal. So let's first open up our terminal here. Well, let's see this document. Well, a virtual environment, as you can see, is a cooperatively isolated runtime environment that allows Python users and applications to install and upgrade Python distribution packages without interfering with the behavior of other Python applications running on the same system. So what this means is that you can have different runtime environments that you can use for different projects with maybe even different versions of the same package, and they don't have to collide or interfere with each other. So you can work even with different versions of the same package and do different things and try different stuff without breaking anything on your other project. And that's very nice because it usually is the case that some Python modules or packages require some versions that might be newer or older than the ones you're currently using for some project. And that is a very nice feature that actually already comes with Python installed. So you don't have to install any extra stuff if you want to use a virtual environment, because one of the things that come with Python is VM, which is a built-in module included from Python 3.3 onwards. And the Python 3 is the standard now for Python, as you know, because most of the applications just like maybe 1 year ago or 2 years ago dropped Python 2 support. So you shouldn't be using Python 2 at all. You should be using Python 3 by now. Well, it's designed for creating lightweight virtual environments, and this is the recommended tool for creating virtual environments. And there are as well other options. Well, much more. I think that I forgot to include here poetry, but I mentioned it here somewhere. It's well, I will mention it later. But I think that Ramiz likes using poetry, so he might want to have a comment at the end regarding that. So let's see. Since Python already comes with VM included, we will use that during this tutorial. As I said, you can go on and open your terminal, whether it's PowerShell or Unix. I just have mine here. My terminal might look a little bit different from yours. I use Fish Shell, but you don't have to. You can just follow along if you use Bash or ZASH or another terminal. We can figure it out if something doesn't work the same way. So let's first look at our Python version. So we can do that by doing this. And on Windows, you just do the py command. I don't know why, but it's that way. And as you can see here, I'm using Python 3.9, but I guess that you might have, if you just install Python today, you might be using Python 3.10 probably.
Hey, Ronaldo, can you increase the font a little bit on the terminal?
Sure, sorry.
No, no worries, thank you.
So it should be better now, I think.
Yeah, it looks good now.
Okay, so we have the Python version here, and now we can view the currently installed packages in our Python distribution by using this command, python 3 -m pip list. So let's do that. So as you can see, I have lots of Python packages installed on my Python by default, and you might have fewer packages if you installed it today, and it's fine. It's just that I've been working for quite a while with Python. This, well, is the result of that. And then we can create a directory for our virtual environment. And well, this command is very well known in the terminal environments, make dir or make directory. And well, I think I already did this tutorial, so I guess I'll just delete my directory before going forward. Yeah, I already had it installed, so let's delete it and then we can continue. Okay, so let's create our directory, and this -p, what it does is creating the parent directory. So here we are creating two directories, one which is this one, and the other which is this one, which is contained within this other directory. And the -p makes sure that this directory is also created at the same time as this one. So let's do that. And on PowerShell, you don't need the -p. You can just do it without it. Now let's create our virtual environment. So I created a folder for the current Hat Week, and also a folder for my virtual environment, which I called py39 -hack. So let's create our virtual environment by this cd command is change directory. So we are going into this directory. And now we are, as you can see, in this directory. And now let's create our virtual environment with this command. So I've created my virtual environment, and as you can see, here I have just one folder, which is the one I created earlier. And if we see inside this folder, we see that other things were created as well. And this is the result of this command, which created the virtual environment, and it created 3 directories and a config file. And probably the main directory we're concerned with at the moment is the bin directory. So up to now, are there any questions about what we have seen? I don't know if I'm going too fast or too slow. Okay.
I think there's one thing I want to point out, if I missed it already. When you're creating the virtual environment, the Python version that is used for the virtual environment is the same one that is used to create the virtual environment. So as Ronaldo showed at the beginning, his Python 3 is currently pointing to 3.9, and that's why the new virtual environment is also going to be in Python 3.9.
Yeah, that's the case. And the Python or the virtual environment, it's created with that Python version because we are using Python 3 here, right? And that's the same Python from the previous command. The Python 3 minus version is the same software.
I do have a question, Ronaldo.
Yeah.
So when you do that and you create the environment, does it base the predefined packages, installed packages on the Python environment that you started with? So does it have all of the modules loaded, not loaded, but available?
Yeah, I'm not sure. I'm not sure about that one, but we can check with this command. So let's skip some part of our tutorial and see.
Well,
it's not. Yeah, it's not installed.
So to answer that question, there is a flag for that you can let the virtual environment inherit the site packages of the Python distribution. So let's say that again.
Of the parent.
Yeah, with a caveat. For example, if you created the virtual environment using the main Python distribution, okay, and you set that flag, then those packages would become available. But if you create a virtual environment from another virtual environment, the new one will not include the site packages of the parent virtual environment. Does that make sense? It's a little weird.
Yeah, you repeat what you just said, if you don't mind.
If you create a virtual environment from a virtual environment, the new virtual environment will not contain the site packages of the parent virtual environment.
The precursor to the virtual environment.
But if you do still include that flag, it will include the site packages of, for lack of a better term, the root Python distribution that created the first.
So it will skip the intermediate environment?
Yeah, I ran into this problem about a month ago, but yeah.
Okay, so it always goes back to the parent, the main parent.
And I don't remember the flag that you use while creating the virtual environment, but if you edit this py-vnf-cfg, there's a boolean in there that you can turn on and off to turn the site packages on and off.
Okay. Yeah, I've seen it not on the command line, but in the PyCharm.
Yeah.
Which I know you're going to talk about. PyCharm, you can click a button and tell it to inherit the packages.
Yeah. All right. Sorry, Ronaldo. Go ahead.
Yeah, it's fine. I like discussions. So as you can see here, we don't have the installed packages from before. So let's just ignore this little part of the tutorial. I will get into that later. So going back to step 4, No, step 4, no, we already did step 4. Going back to step 5, we can see the contents of the folder within our hack week 2022. So if we do list the contents, we can see that there are 3 directories and 1 file. And if you do that on Windows, you will see sort of a different output, not necessarily the same folders and config file, or well, the config file, the name is the same, but the other parts of the output are different. I think most of them. So yeah, don't worry if you're in Windows and you don't see this bin or include the same way I do in Mac. So now we want to activate our virtual environment in order to be able to install packages and to actually use them. So there are many variations of this activate script. If you are on Bash or ZASH shell, which is the default for Linux and, well, Linux and Mac, you can use this command. If you are using fish, which I'm using fish, you can use this command. Sorry. And you can see all the other commands. So I guess that most people will be using Bash and the PowerShell versions. So let's see. In my case, I have to use the fish version, which is this one. But as I said, if you are on Bash, which you probably are if you are using Linux, you just have to do this command. But I will do this because I'm on fish. So now you can see that. And if you are on Windows, you have to use an extra command to be able to execute a script. I don't know why, because I don't know. I don't use Windows since a long time ago, but I ran into this problem while doing this tutorial. So I guess that you should probably try using this command as well if you run into a problem, and then you can execute you can activate your virtual environment from your terminal PowerShell using this other command. Yeah, so for Windows, you have to use 2 commands. So now you can see that our virtual environment is activated, and you can see that because here I get the Pi39 hack name before the current directory name. So that means that it's activated, and we can see that because if we run again the commands we ran earlier and see what we have installed here, we see that we only have these 2 things installed as opposed to the other many packages I had before. So they are 2 completely different virtual environments or runtime environments, and you don't have to worry about any other thing you might have installed previously that might cause trouble with your current project. So, and to deactivate the virtual environment, which is also important because maybe then you want to change to another one or use another set of installed packages, you can just do deactivate, and we deactivated the virtual environment, so it's not appearing here anymore. So installing packages to the virtual environment is just like installing packages to any Python installation. But you have to first activate your virtual environment, because otherwise you would be installing them to your global Python distribution, and you probably don't want to do that. So let's now activate our virtual environment. And maybe let's install a package. I don't know, maybe we can install a NumPy. So we can do that by using pip install. I'm sorry about the, okay, this this is weird. But install NumPy, and if we do the same command from before, the pip list, we see that now we have NumPy installed. So that's great. And well, this warning is just telling us that we have a Python pip version, which is kind of old, but we have the 21st version, and they are suggesting to use the 22nd, but that shouldn't be much of an issue, and you can just do that. You can upgrade your pip by just doing this command, and then you wouldn't be getting the warning anymore.
I was going to add a comment on that. I've noticed this myself, that even if your pip is upgraded in the main distribution, for some reason the virtual environment pip is always back version. I don't know why. So that error that warning that you see about the pip being out of date happens almost every single time you create a new virtual environment. It actually happens almost every single time you try to pip install stuff, because they update it so frequently.
Mm-hmm. Yeah, it also happens all the time to me as well. But you can just fix it by using the command they suggest. So that shouldn't be much of an issue. So let's see. Well, this is the last part of the tutorial. Modifying the Python path of your virtual environment. So we might want to make edits to some package, such as PlasmaPy, to, I don't know, test new features or implement new things, or try to change thing that it's already within the package. And it might be troublesome to actually like install the package again and again for every small change you make. So there's a way of doing this, modify the source code of the package and actually use that without having to reinstall every time. And that way is by modifying the Python path for our virtual environment, or you can also use that for the global Python installation, but I wouldn't suggest doing that. So now that we have our virtual environment activated, we can go on and modify the Python path and then import maybe PlasmaPy to our installation of our virtual environment and see whether we can use it or not, without installing it to our virtual environment, and just including the path to the project within a file called, well, whatever name you want to give it, .pth. So let's see. Let's go change the directory onto the lib Python 3.9 side packages. So this should be actually not lib, but should be, I'm sorry. It should be like this, by 39 pack, like that. So now that we are in the side packages of our virtual environments, because this is the directory of our virtual environment, we can create a new file, and then we can name it maybe PlasmaPy. So as I made a comment before about invoking VS Code from your terminal, and you can do that by, let's see, by using this command code, but that doesn't come by default. You have to install it. So you can do that by doing, in the case of Mac, Command Shift P, and then you search for code, and then you will see this option, shell command install code command in path. And if you are on Windows, I think the keyboard binding is Control Shift P, and that should pop this open, and then you can search here for code as well. And you just do install code command in path, and then this will add it to your path, and then you have to restart your terminal. So you just close it and open a new one, and then you should have this code command on your terminal. But if you don't, And if you're on Windows, you can use Notepad to open a file. If you are on Mac, I think you can use BI. By default, I guess it comes installed, I think. Yeah, I don't use this, so I cannot give you like much guidance with this. I just use VS Code, so I would use that. So to create a file, you can use either touch, which is a command that it works on Linux and Mac, and you can just then create your PlasmaPy file.pth. And as you can see, that created the PlasmaPy.pth file, but you can also use directly codes and create a file like that. That creates the file here. So now the file is created. And well, if you are on Windows, you can use Notepad PlasmaPy.pth, and that should create as well the file. That might have a pop-up that is asking for confirmation to create the file or not, and you just click yes, and then it will create the file for you as well. So now that we have our file open and created, then,
by the way, there is something I should mention. When you get a pop-up like that for a file creation, we do not see it on the shared Zoom screen. Error dialogues do not appear.
Okay. Yeah, but I won't get any pop-ups because I'm not using Windows. But yeah, thank you for the comment. It's important as well. So now that we have our file open, and as you can see, it's within the Py39 hack directory, then we have to add the path to our PlasmaPy repo that we downloaded earlier. And you might not have this in case you haven't ever used PlasmaPy. But if you go to GitHub and search for PlasmaPy, you can just download it, I guess, by downloading a zip and then decompressing the zip, and then, well, that's about it. If you don't have Git or anything fancy, you can just download a zip if you want. I guess that tomorrow you will see how to do this with Git in the Git session. But in my case, I already have PlasmaPy. Sorry, I already have PlasmaPy installed, or well, not installed, but I already have it on my system. So I have it here. So what I have to do is just copy this path to the root of PlasmaPy.
Ronaldo, can you make the font a little bigger on the second terminal?
Yeah.
Thank you.
So what I did is just enter my PlasmaPy directory, which, as you can see, is the same, has the same contents as this repo. It has the docs that include the licenses and all other files that are here. So you have to copy the path to the current directory, which is PlasmaPy, onto our file that we just created. So that has to be an absolute path. It cannot be relative path. And when you do that, you just save the file and close it. And then you actually have now PlasmaPy in your virtual environment without actually having installed it. So our virtual environment is here, as you can see, activated. And now we can do something like Python. So this opens the interactive terminal of Python. and we can see if we have PlasmaPy here or not. And we do, as you can see here, we have PlasmaPy. And now we should be able to import it only if we have all the virtual dependencies, all of the dependencies installed on our virtual environment. So if we want to install all the dependencies, this shouldn't be so difficult. You just have to go to requirements, install.txt. So if you go to a PlasmaPy directory, root directory, and then you go to requirements, and then you go to install, you just copy this on and create maybe a new file. And let's see. You enter your Hack Week directory and create a new file, maybe called requirements.txt. And then you copy these dependencies onto here, and then you save the file and close it, and you should be able to install everything on your virtual environment by doing pip install -r requirements txt, and then you are installing all the PlasmaPy dependencies. So now we should be able to import PlasmaPy from our virtual environment. I guess that I have to wait for it to complete. Let's see. And I guess that's all for my part. Well, I also mentioned that some people prefer to use poetry instead of VM. So you might want to have a look into it. And here are some useful links at the end. Well, this is an optional part because I was told that we are not going to use Jupyter Notebook so much during the week. So I guess let's continue installing the packages. I don't know how much it will take. Okay, it's done. So let's just in case deactivate our virtual environment and activate it again. Or let's call Python from here. Now import sys path. We have PlasmaPy here, as you can see, and then we can do import PlasmaPy. And well, it takes a minute or so to import it, but it should work, I think. Are there any questions so far about what we have covered or about anything?
I don't have a question, but I did find a an add-on that allows you to manage your virtual environments in Visual Studio.
Yeah, that probably is easier than doing the terminal. I don't know if you can share the link to it.
I don't know how to share links to. It's just called Python. I don't know how to share links to plugins.
Okay, so as you can see here, we imported PlasmaPy and we called version, which gives us this version, which is the one that I have on my system. So going back to Will's comment, let's see. I guess that you're referring to an extension here.
Yes, do the type Python environment. Yeah, there it's down. It's the 5th one down or something.
This one?
Yes, sir.
Okay.
And it'll just add a new icon on the left side over there. And if you hit the refresh button up at the top, it'll show you your installed environments, and you can quickly create a new virtual environment from one of your installed environments.
And how can I like install packages onto it? I guess that I just open the terminal here and activate maybe one of those.
Yeah, if you hit the disclosure button, it shows you the packages that are installed inside there. So there's a disclosure arrow to the left of the icon.
Mm-hmm. Oh,
and then there's the list of packages.
Seems nice. I haven't used it before, so I don't know.
No, I just went and looked. I haven't either, but I knew that Eric was going to showcase PyCharm's ability to virtual end, and so I'm competitive.
The war begins.
Yeah, I've got something else I wanted to show in VS Code at some point too, before you show yours.
You know what's funny though is I really don't use PyCharm to manage my virtual environments. I do it with the same tools that Ronald's been showing.
Fascinating.
I hate command line, but there's a handful of things I just find it easier to do. It just works with my brain, so I stick with it.
Okay, so I guess that if there aren't any questions, we can end for now, unless someone has a question. Okay.
Thank you, Ronaldo. Ramiz, is there anything else you wanted to add? Okay. All right, that concludes for today. Tomorrow is going to be all about Git and GitHub. So we'll cover all the fundamentals of Git, and then all the interaction of on GitHub. So between today and tomorrow is going to be the foundation for days three to 5, when we actually get to start developing the hack package. So hopefully that will give you all the tools that you need to be able to write and develop code for the remaining packages, or for the hack package. Nick, is there anything you want to add?
Nope. I think it's all good.
I will reiterate again that day 3 is going to be the formulary day. So that's the idea, that we will build our own formulary for the hack package. As Will alluded to, we're going to use PlasmaPy's formulary as a template, just so y'all have a reference to work off. So you don't necessarily have to create new code from scratch, but we're not limited just to what functionality currently exists in PlasmaPy. It gives us something to work from and learn from. And then days 4 and 5 are hopefully going to focus on new functionality that may not even exist in PlasmaPy. We have, let me share a window. Give me a second. As Will showed earlier, if you go to github.com PlasmaPy, and you go to the hack week, and if you go to issues and you select the 2022 label, all these are projects that we have currently seeded. So these are potential things that we can work on for days 4 and 5. If you have features that you're interested in and would like to develop code and get assistance from us, feel free to open an issue here and just add it. So it's all you have to do is you just click the new issue, and then you just fill it out, give it a title, and explain what you're looking for, and then we can, if there's enough interest, we can pick it up during days 4 and 5, and we can work through the details. All right. Thank you. Are there any questions? All right, we can conclude for the day. I think a handful of us can stick around if people want to work on getting their environment set up for tomorrow. Otherwise, we'll see you tomorrow. And thank you for joining.
Thanks a bunch.
Thank you. Have a good one.
Yeah, if anybody wants to set up their WSL environment, I'll be happy to stick around.